Welcome to GATE 2022 solutions. Since last 1 year you were preparing and finally you appeared in the exam today. We all know this year it has been lot of disturbance in the preparation. Offline, online, some of the students who joined the offline classes but frequently lot of interruptions. But कुछ नहीं कर सकते थे. This was COVID effect and COVID was highly unpredictable. Fortunately, now the COVID conditions are becoming milder and most of the people are now getting normalization. Now, the situation which is today, you have appeared in the exam and you want to know what will be your performance, how many marks you are getting, what is your rank prediction. So, all these things must be triggering in your mind. Dear friends, today GATE faculties will discuss solutions of the GATE 2022 of electrical engineering in this video. These are memory based questions. All the questions are not available, but most of the questions we have found and the students have shared the questions, and based on that we are going to discuss the answers and solutions. But before we start the discussion, I want to tell you a few more things. Life is all about the efforts and success. Efforts always bring success, maybe sooner or later or it may take more time. तो आपको efforts stop नहीं करना है. You have to continue. Last 1 year, those of you who have been part of the GATE, we have tried to support to the best way. आप लोगों को पता है कि जिनकी offline classes थी, जब नहीं offline हो पाई, we provided the live online classes. And again, when the offline classes were permitted, we allowed them to attend the extra classes also. और जिन लोगों ने पूरे साल क्लासेस की हैं, अगर अभी भी आपका कोई सब्जेक्ट छूट गया है, इफ यू हैव नॉट बीन एबल टू डू कंप्लीट एंड यू वाज द पार्ट ऑफ द GATE, देन डोंट हेजिटेट एंड डोंट डिप्रेस. वी विल सपोर्ट यू. फिर आपको एक बार पढ़ाने की कोशिश करेंगे एंड वी विल हेल्प यू. द वैलिडिटी ऑफ द लाइव ऑनलाइन कोर्सेस and the validity of the videos for the classroom course students was till GATE exam or ESE prelims exam. But looking on the importance and looking on the request, we have already extended the validity of the 2022 courses till 31st of March. इससे आपको हेल्प मिलेगी कि जो सब्जेक्ट्स आपके छूट गए हैं, those which you have not been able to complete till now, आप उनको कर सकते हैं, रिवाइज कर सकते हैं. फर्दर अगर एक्सटेंशन की जरूरत पड़ेगी बियॉन्ड 31st मार्च, देन वी विल प्रोवाइड सम ऑप्शन बाय मेकिंग नॉमिनल पेमेंट्स. यू कैन इंक्रीज द few more months or few more week the validity period of the courses. So this is one part. Those of you who are planning to appear in the GATE and ESE 2023 for the next year, you must be beginning the journey, or you have prepared this year but your preparation was not up to the expectation. Then you are going to get one opportunity to get the scholarship from the GATE. So GATE is going to conduct national scholarship test. Yes, on this month itself, and last date to apply for the scholarship is 19th of February, and on 22nd February we will conduct a scholarship test for the online live courses, and on 27th of February we will conduct the scholarship test for the classroom courses. So if you are interested, you can apply. In classroom courses there is provision of this 100%, up to 100% scholarship, and up to 50% scholarship is possible in the live online courses. So this may help you. GATE will introduce the rank predictor and this GATE 2022 rank predictor. So as soon as we will be able to get the complete question paper, and we will be able to provide you mechanism where you can test how much marks and how much score and what will be your rank. So that also will be activated soon, as soon as we get this. The questions which we have obtained are the memory based, and you all have shared the questions. These are memory based. There is definitely chance of error or some discrepancy. So whatever answers will be given, they will be based on the data obtained. Maybe certain error there, but may not be. It all depends. So we are putting our best efforts to provide you the solution of the memory based questions, but there is still scope of the further improvement, because once we will get the question paper, we will provide the complete solutions. In this video, today's discussion, all the subjects will be discussed by the concerned faculty members. In some subjects there are multiple faculty members, they will join. Few members are unable to join today because they are not feeling well or they are out station. Otherwise most of the members are available. Few faculty members are not available because they are either out station or they are not well. So these are the things which I wanted to share. Then dear friends, क्योंकि आप मेडी जी के स्टूडेंट्स रहे हो, वी हैव पुट आवर बेस्ट एफर्ट्स, चाहे आपको क्विक रिवीजन कोर्स की रिक्वायरमेंट हो और इट वाज द नीड ऑफ द सॉल्विंग योर डाउट थ्रू द टेलीग्राम ग्रुप. यू हैव सीन हाउ डिसिप्लिन was this guided mechanism of the telegram, where we gave the support since last 45 days and still it will continue till the engineering services prelims examination and time to time for the upcoming exams. You have seen that all the courses of MEDG were to the point. We don't waste even a single minute or single second, and all the classes are conducted by the senior faculties who are expert of their field. So this is difference between the MEDG and the other places, the quality and the best utilization of the time. The study material which we have designed is by the research team. The test series, you have seen that how good it was. So all these are the things which are the part which make this institution different. Now coming back to the discussion today, you are waiting since long. So now I will invite to Mr. Kiran Kumar and Mr. Y. Naresh. They will discuss the network theory and they will start the discussion of this, and one by one subject we will keep on discussing and the other faculty will keep on joining. So थैंक यू वेरी मच. अगर आपको ये वीडियोज़ और ये डिस्कशंस अच्छे लगे तो आप लाइक और शेयर भी करिए एंड रिकमेंड टू योर फ्रेंड्स ऑल्सो. आप अपनी कमेंट भी दीजिए, आपकी कुछ जो भी आपके आंसर्स हैं, प्लीज़ गेट इन्वॉल्व. इट इज़ लाइव डिस्कशन, सो आप भी अपने आंसर्स उसमें देते जाइए. सो वेलकम किरण एंड वेलकम नरेश. या प्लीज, थैंक यू सो मच.
Good evening, dear students. I hope you did well in the exam. This year in electrical circuits, very easy questions were given. I think you might have attempted. Okay, come to the first question. Now in the first question, you give the statement as a t equals 0 seconds switch is closed. A t equals 0 seconds switch is closed. What is our requirement is a voltage across the 6 ohm resistor, voltage across 6 ohm resistor under steady state condition, Now whenever they ask a steady state condition, first you have to focus on given source. But a given source type is a DC source. Now for the DC source under steady state condition, how this capacitor behaves as a open circuit. Under steady state condition, this capacitor behaves as a open circuit. Whenever the capacitor is open circuited in this branch, no current will be circulated, no current is circulated. Then if you develop the circuit, if you develop the figure at steady state condition, now steady state condition means indirectly we can conclude as a t equal infinite condition. Steady state means we can take a t equal infinite condition. Now under steady state condition, just now we concluded the capacitor behaves as open circuit. The capacitor branch is open circuited. Now what is our requirement is a voltage across the 6 ohm resistor, voltage is 6 ohm resistor. To make calculation simple, either how the 6 and 3 both are connected in the parallel, 6 and 3 both are in the parallel, then what is equivalent resistance equal to 2 ohms, equivalent resistance is 2 ohms. Now voltage across this one, voltage across 2 ohms, let us name this one A and the B, let us name this as A and the B. Now in this branch resistance is a 10 ohms. Now what is given source voltage is a 10 volts, given source voltage is a 10 volts. 2 ohms. What is the requirement is a voltage across 6 ohm resistor. Here the voltage across this 2 ohm resistor, voltage across this parallel combination, both are the same, both are the same. Now you can easily conclude. देखिए इधर total voltage कितना है इधर 10 volts. Now these are 2 ohms. In this branch no current will be circulated. क्यों बोलते हो? Capacitor is open circuited. Capacitor open circuited. The total voltage distributed between the first one and the second one. Both are having the equal value of the resistances. When the resistors are same, then total voltage will be equally distributed, Then in this example, voltage across this one is equal to how much here? 5 volts. Voltage across this one is 5 volts. The same voltage, here the same voltage is present for the 6 ohm resistor as well as 3 ohm resistor. क्यों बोलते दोनों कैसा है? Parallel combination. Okay. Sir.
Come to the second question. The second question is based on the KCL and KVL only. Just is given a 75 volts in series 2 kilo ohms and 1 by 2 V1. The current is flowing. Here asked the question is find V1. The volt across 8 kilo ohms is. So here is what the first step is, V1 is equal to, first step is V1 is equal to 8 into what is the current is flowing through the 8 kilo ohms is I. This is I. So you have to find out the current I. So you write a loop equation here, then get a current I value. Is very simple. 75, the current is flowing here is a minus 2k into I, and here is a plus minus, here is a minus 0.5 V1 is equal to 0. From this you write a I is equal to 75 minus 0.5 V1 upon 2k. Just substitute in this, in place of I, 75 minus 0.51 V1 by 2k, you get a V1 is equal to 100 volts. You are just using KCL, KVL and Ohm's law. The current is flowing, this one is here is 0, here is current is I is coming, I is outgoing, the current is I is equal to 0. Just a similar type question is discussed in a GTQ also. Okay.
Many students are asking regarding the difficulty of the paper. Now if you come to electrical circuit point of view, when compared to last year, this year very easy questions have been asked. Okay. Now in this example, what the resonant frequency is given, bandwidth is given. Now if you know the formula for the relation between the resonant frequency and bandwidth and quality factor, directly you can conclude the answer. Now what is the relation for this one is this quality factor is equal to resonant frequency by bandwidth. I hope you might have seen that GTQ questions. The same question have been discussed. Now in this example, what the resonant frequency is 150 kilohertz. 150 kilohertz. Now what about this bandwidth? Bandwidth is a 600. Then if you simplify this one, quality factor is equal to 50.
The next question is an inductor having Q factor of 60. That means inductor is given, means there is a coil is having the quality factor is 60, is connected in series with a capacitor having a Q factor of 240. The overall Q factor of the circuit is, the circuit is similar, just like here the quality factor means is the coil, here is the coil, the quality factor is given is here is the 60. The capacitor means here is a lossy capacitor, there is a represented by resistance in parallel with capacitor, is connected in a series. The quality factor of the capacitor is given here 240. Now the question is asking what is the overall quality factor of the circuit is. We discussed in the class also this is. So the formula for this one is Q is equal to Q coil QL into QC upon QL plus QC. Maybe you get a doubt how to get this one is. So one is a derivation is there, you have to find out the transfer function of the circuit, find out the zeta value, and what is the relation between zeta and the quality factor. The zeta is equal to 1 by 2q. From that you get a Q is equal to QL, similar to the, not exact, this is values, just equal to QL QC by QL plus QC. Now you substitute the values 60 into 240 upon 240 plus 60, here 300. So you have to simplify it, you get the answer is 48. This is also about the quality factor. Previous question also quality factor. So previous question already discussed, the Kiran sir in a GTQ also the quality factor is. These are the types of questions are given in a network analysis, and some 2 questions from the 3-phase circuits also. So 3-phase circuits problems discussed by the power system lecturer. Okay, thank you.
Okay. Hi dear students, we are dealing about analog electronics. Okay. In electrical engineering, we got I got around 5 to 6 questions with me. Nearly around the marks I am expecting 6 to 7 marks. Okay. In this, we are going to discuss about, we have nearly 5 to 6 questions. In that, one by one, we will try to start the questions. Okay. Let us see the first question, which I got the information from the students. It is based on a MOSFET question he has given. That is, for an ideal MOSFET bias in saturation, the magnitude of the small signal current gain for a common drain amplifier is asking. So most of the students will think a common drain voltage gain, they will think because common drain have a speciality, it is a buffer, voltage buffer we call, voltage gain will be unity for that. But he is asking not voltage gain here, voltage gain AV will be 1, because common drain or common collector will work like a buffers, correct. But he is not asking voltage gain, please remember that. Most of the students may be in this trap, okay. They will write 1, that is wrong. He is asking here current gain. If they ask current gain that is AI for a common drain amplifier, the output will be IE, IS we can say, because common drain will have output current as source current and IG will be the input current. And most of the students knows that the input impedance is very high for the MOSFET, and he said ideal MOSFET, so gate current will be 0 naturally. So it will become the current gain is IS by IG. So IC current IS by 0, it will become infinite. So please remember, the 1 is not the correct answer, infinite will be the correct answer, because current gain IG cannot go into the MOSFET. So I am expecting according to the options, I got the options like this, D will be the correct answer for this, okay. Infinite will be the correct answer. So it is clear. I think we will go to the next question in analog electronics. We will go to the next slide. Yeah, this is the second question we can see, okay. That previous common drain question we have already discussed in the classroom. So many times we will try to instruct to the students, voltage gain, current gain will be different for common drain amplifiers, okay, or in BJTs we call common collector. Now the second question is a simple question, again BJT question. I remember that this type of question came for EC students in a GATE exam. It came again for electrical students, same question. I think most of the students who have studied well, this question is very simple for him, okay. If you see the circuit correctly, the diode and one more diode he has given in this direction, what will happen for this circuit analysis I can show you. In the next slide I will show you. He has given circuit like this. This is D1 first diode, next he has taken a resistor as a load and one more diode D2 is there. So maybe some students are telling, they have given options saying that VA greater than 0 what happens, VA less than 0 what happens. Maybe it is like a MSQ question, I do not have that options with me, but analysis I can show you one time which will clear your mind. So if I go for positive half cycle, D1 and D2 will be on, D1 and D2 both are on, okay. If both diodes are on, I think it is an ideal diode I am taking, because I am thinking that they have given like an ideal diodes. If it is an ideal diode, this is short circuit D1 and we have a resistor here and again short circuit at D2. This is VIN. So we are expecting output will be equal to input. This is about the positive half cycle response. If I go to negative half cycle, so D1 and D2 both will be off. So both diodes will be in reverse bias, okay, such that the circuit looks like this. D1 is open, a resistor and D2. This is VIN and this is your output, it will be 0. So I am expecting these are the correct conditions for the circuit. If you want to know the output waveform for this, this is your input sinusoidal given. He is telling that positive half cycle whatever you are giving, that is coming as a response. Negative cycle we are not getting any response. So I am expecting it behaves like a half wave rectifier. It is a very easy question. I think most of the students have attempted this question, okay. I am expecting this can come like 1 mark question I am expecting. So we have completed 2 questions, one is from MOSFET common drain amplifier, second one is from a rectifier question. We will see one more question, question number 3, we will go for question number 3. You correctly see this question. From all the questions I think this question only looking very interesting, which is a typical question for the students, okay. Most of the students will get confused with this question. Let us see how to deal this question now. The output impedance of a non-ideal op amp, whenever the person said this word non-ideal op amp, the voltage gain inside the op amp is not infinite. Please remember that. Voltage gain will be infinite inside the op amp. When it is an ideal op amp, it is a non-ideal op amp. So, infinite nahi hai, AD will be some high value, and is denoted by Z0. He is asking you the variation in the amplitude of Z0 with increase in the frequency. Z out with respect to frequency, how the response will be is asking. Okay, what is the simple procedure we can do for this? We will see. Can you see that this circuit is a negative feedback circuit? First point, most of the students knows that, and this circuit can also be called as a voltage follower. Number of times when I am teaching the class, I told you this is a good application. We call it as a buffer. It's a voltage buffer circuit. Most of the students will recognize this circuit. A voltage buffer circuit in topology networks, we call it as a voltage series network. Voltage, this is voltage, it is connected in series because positive side you connected, so it's a voltage series topology. Let's see how to find out the Z out response with respect to frequency. What is the simple trick for that? Let's see the solution for it. Let's see the analysis one time. So it's a voltage series. First you have to confirm that it's a voltage series circuit. It's a voltage series. Okay. Why? Because the op amp has a negative feedback, taking the output V0. Positive side here given the input. Positive side here given the input, and it's connected with a negative feedback. So it's a voltage series topology. Is asking here your Z out with respect to frequency. Just we can write Z out with feedback can be represented as Z out divided by 1 plus A beta. You can write this response because in the classroom I told you already, voltage at the output, voltage means output. The connection for voltage will be shunt. Voltage means shunt connection at the output. For a shunt systems, I think the output impedance will decrease in a negative feedback, which is R0 by 1 plus A beta factor. If I take Z0, Z0 by 1 plus A beta. But for a buffer circuit, the beta factor which we have here, beta factor, which is Vf by V0 will become 1. Because the feedback voltage whatever you have taken, the input voltage, output voltage both are same. So beta factor will be 1. This is a feedback factor. This is a feedback factor. Okay. So here beta is feedback factor, A is called open loop gain. A is called open loop gain. So we have total information with us. Just I want to interact with Z0 with respect to frequency. How to do it? If you have the gain response for an op amp, first of all we will see the gain response, A versus frequency suppose. Everybody knows, I think, a op amp is a low pass response. It cannot be high pass or band pass. Band pass is a concept will come for RC coupled amplifiers. There is no coupling capacitors in this concept of op amp. So it's a direct coupled system. So the response may be like this. This is the response. Practical op amps if you take, it is nearly, we can take 10 power 6, the highest gain of an op amp. You can take 10 power 4 to 10 power 6 something. This is a gain where the response will be like this. Have seen that initially the gain is constant at low frequency. When it is going to high frequencies, the gain is falling down. This is the behavior of your open loop system gain. Then we can write now Z out with feedback can be written as Z out divided by 1 plus A we can write, because beta is becoming 1, A is a higher quantity. So now we have to track this A value, how it is changing. According to that, your Z0 how it is changing we can find out. Okay. Z0 is a without feedback system output impedance, how it is falling with A value. If you see first concept, if A is first case 1, if A is first constant at low frequency, we have observed that A is constant at low frequency. If A is constant, then your Z0F behavior will be Z0 divided by 1 plus constant. So this total became a constant value. So that means initially you must get a constant value. Okay. Initially at low frequencies we are expecting a constant value. After that what happens is, if A is now decreasing after certain frequencies, the next case is A is decreasing after FH. As A is decreasing, then what should happen to Z0F? Z0 divided by 1 plus A is decreasing. That means the denominator is decreasing, then automatically your Z0F will increase. This is the next step. Okay. And at the final stage, when you reach to infinite, what happens? When you reach to infinite, that is A is as the frequency is reaching to infinite, A will become 0. At very high frequencies, close to the infinite frequencies, it will be 0. If A becomes 0, then what is the Z0F behavior? Is Z0 divided by 1 plus 0, which is equal to Z0. So finally it has settled to a Z0, again a constant value at infinite stage. So I am expecting we got 3 steps now. With this we can estimate the response. The response can be like this. This is Z0 versus frequency. Z0F we can say frequency. First initially we got a constant. That is some Z0 by 1 plus A. Initially we have a constant like this. After that your impedance has been increased, because as the gain is decreasing, impedance is increasing here, Z0F. After that again Z0F became Z0. So finally at very high frequencies you will see here some Z0. So I am expecting this type of behavior can be expected for this problem. So this is a very interesting question I have seen. Maybe if you get this click of voltage series technique, and if you know Z0F equal to Z0 by 1 plus A beta, we can do like this. Otherwise you can do one more way, that is gain low pass system transfer function you have to take with respect to frequencies. It will take more time for you to calculate all these things. Just by gain technique, if you can solve it, will take less time to solve this problem. I am expecting, according to this, the options, if you see, these are the 4 options I got from the students. Okay, these are the 4 options. The first option is wrong, because constant, falling and constant, that is wrong. Continuous constant is a bad answer. Ramp is a bad answer, it can never happen. So only A or D. D is looking correct for the question. Okay. So these 3 questions, I think D will be the correct answer for this question. Now my colleague Iftikhar sir will take the remaining 2 questions. Okay. Thank you.
Thank you, Rajkumar sir.
Yeah.
Sir has discussed already 3 questions. There are 2 more questions which came from op-amp topic, and I will be discussing those other 2 questions. This was the 4th question from op-amp topic. This is 2nd question from op-amp and 4th question in our sequence. And here the question is like op-amp is ideal, and we have to find out the current gain I out divided by I in. And I am assuming that these are the current directions given in the question. These are all memory based questions which we collected from our students. So there can be some error in current directions, etc. But when I solve this question, I am going to take these current directions. Okay. And there are 2 capacitors. This is CF and this capacitor is C0. So by assuming this data, we will try to solve the question. Now this op-amp circuit is a negative feedback op-amp circuit. So we can use our virtual short circuit concept. And if you apply virtual short circuit concept, then inverting node will be at a 0 potential. Okay. If I name this node as A, then that VA will be equal to 0 because of virtual short circuit. Then we will assume this node at a potential Vx. Okay, let us consider this voltage as Vx, and then this input current, it has to flow through CF only, because input current of op amp is 0. Everybody knows from properties of ideal op amp, input current for an op amp is 0. So if you take input current of op amp as 0, then we can say same input current has to flow into this capacitor CF. This current we can take as I in. Okay, and then if you notice voltage across CF, it will be Vx minus Va, but that Va is 0, so voltage across this capacitor will be how much? It will be simply Vx itself. Then we can apply current equation for a capacitor, I equal to C into dV by dt, or if you write voltage, it will be 1 by C into integration I dt. Okay, so let us use that technique here. Vx is equal to, it will be 1 by Cf into integration I in into dt. This will be the expression for Vx. I repeat once again, voltage across this capacitor will be simply Vx minus 0, or it will be equal to Vx itself. We can show it in this way. It will be equal to Vx itself, and that Vx I have written in terms of input current, 1 by C into integration I in into dt. Now this input current is like a constant here, it's a constant current, so it will become Vx equal to, that I in is a constant, if you take it outside, it will become I in divided by Cf into integration dt. That integration dt, it will become simply T itself. So this is the voltage Vx. Now same voltage Vx will be there across C0 also. If you look at this capacitance C0, same Vx will be present across C0 also. So in this way I can tell that I know voltage across C0. If I know voltage across a capacitor, then I can calculate current in the capacitor. So I out will be C0 into dVx by dt. I am using current equation of a capacitor. I out is equal to C0 into dVx upon dt. Okay, I repeat again, same Vx will be there across C0 also. I know voltage across C0, it is Vx, so current through C0, which is nothing but I out, it will be equal to C0 into dV by dt, or I out is equal to, it is C0 into d by dt of Vx. Vx is equal to this much, I in divided by Cf into T. Okay, if you differentiate here, that d by dt of T, it will become 1. So overall this expression becomes C0 into I in divided by Cf. Okay, d by dt of T, it will become equal to 1. So in this way, if you write here the ratio I out divided by I in, it will be equal to C0 divided by Cf. So if you take current directions in this way, then for this op amp question, the current gain I out divided by I in, it should be equal to C0 divided by Cf. Now if you look at options, these are the options provided by our students. These are again memory based options. So if I go with these type of options, then the correct answer should be C0 upon Cf. So in this question, the correct answer will be C0 upon Cf. And I tell once again here, these are all memory based questions. So I am assuming these directions for input current, output current, then the I out upon I in should be equal to C0 upon Cf. So this was an easy question based on negative feedback op amp concept. Then there is one more question which is based on op-amp. Now in this question, input is given as 0.1 volt and we have to tell what will be V out. Now this is a standard op-amp application, we can call it integrator. If you studied in classrooms, we teach it with so much detail, integrator using op-amp. This is an inverting type integrator using op-amp, and if you know the output voltage expression, then solution can be obtained quite quickly. For an integrator, output voltage will be -1 divided by R1 C1 into integration of input. And in case you don't remember the output voltage expression, then you can derive output voltage expression and then substitute input in that. So let's begin in this way. I'm assuming here that we don't remember V out expression. In case you don't remember V out expression for an integrator, then you should proceed in this way. You can call this as node A, okay, and then use your virtual short circuit property. Current in this resistor will be 0 because we are assuming ideal op-amp, input current will be 0. So voltage at the non-inverting terminal is 0 here, current in this R2 is 0, voltage across R2 is also 0. So in that way VA should be equal to 0, VA is equal to 0. Then we will apply KCL at this node A. If I use KCL here, let us call this as some current I1 and this I call as current I2, and input current of op-amp is 0, and these currents I1, I2 we can assume in any direction. Here I have assumed them in this way. Now if I apply KCL, I will get I1 plus I2 equal to 0. If I use a simple trick KCL, we get I1 plus I2 is equal to 0. Then current I1, it can be calculated as, let us call this as V in or Vi. So I1 will be Vi minus 0 divided by R1, Vi minus 0 divided by R1 plus I2, that I2 is current through capacitor. Current through capacitor is always C into dV by dt. So it will be C1 into d by dt of V0 minus 0. Voltage across C1 is V out minus 0. So it will be V out minus 0 is equal to 0. Okay, a simple trick KCL, I1 plus I2 is equal to 0. I1 is current through a resistor R1 and I2 is current through capacitor. Voltage across capacitor is V out minus 0. So in that way I have written current in the capacitor C into dV by dt. This you need to simplify. From here I will be getting dV out upon dt is equal to, it will become minus Vi divided by R1 into C1. Now you integrate both the sides. If you do integration on both the sides, you will get expression V out is equal to minus 1 upon R1 C1 into integration of Vi into dt. Okay, this is standard expression for output voltage of integrator. Most of the students remember this expression. If you know this expression, you would have saved your time, and in case you don't remember the expression, it can be derived in this way, output of an integrator. Now in the given question, input is given as 0.1 volt. It is like a DC. Okay, input is a DC 0.1 volt. So let me substitute here 0.1 volt, it's a DC. That 0.1 I can take outside, so it will become integration dt. I will do it in the next slide. Put V in equal to 0.1 volt, then V out is equal to minus 1 upon R1 C1 into integration of 0.1 into dt. Okay, this integration we perform over some time t. This will become minus 0.1 divided by R1 C1 into integration of dt, it will become t itself. So in this way the output voltage will look like a negative ramp. Okay, this is like a constant, so it is minus k into t. You can say output is in the form minus k into t. It is quite obvious for an integrator. If you apply DC voltage as input, its output will be ramp, and this is a inverting type integrator, and when we apply input as a DC, output will be negative ramp. So if you plot here the output of this particular circuit, it will look like this: V out versus time. Initially output will be like a ramp, output will decrease linearly, it will decrease up to minus V sat or minus V double E. Okay, output is a negative ramp, so output will decay linearly up to minus V sat, that can be taken as minus V double E, and then output will become constant. Now in this question which we collected from our students, there is nothing known whether they are asking output at some time t or they are asking output at some time t equal to infinity. If they are asking output at some time t, that t you can put and calculate the output, but after certain time output is going to saturate. So if you take output at t equal to infinity, it will be minus V sat. So I am assuming here that they have asked the output at some t equal to infinity, I mean steady state. If they are asking steady state output of the circuit, then answer will be minus V sat or minus V double E. Or if they are asking output in this interval 0 to t1, let us call this instant as t1. T1 is the instant at which output becoming minus V sat. If they are asking output from t equal to 0 to t equal to t1, if they ask output for any time in this interval, then you can apply this expression, put t and R1 C1 value and calculate V out. And in case the question is about steady state output or output at t equal to infinity, then answer will be minus V sat or minus V double E. So these were the questions from analog electronics, and I hope that you all have attempted these questions. These were all questions which are like easy ones, except that Z out question, that output impedance question, that required a bit of thinking, but other questions were quite easy. So I again hope that you all have attempted these questions. Thank you for your patience. The next subject will continue after a minute.
Welcome to the Digital Electronics Solution session. The questions are very easy for the electrical branch digital electronics questions. You can see the questions there. Without using the pen paper also you can do like that the thing. That is the way the questions were asked. Here if you observe the one question, it is there on the screen here. You observe this one. Here this is mod 2 and mod 5 up counter and are cascaded together. The resultant mod value what it is. Actually the question is related to the cascading counters. As you know, when counters are cascaded, then what will be the mod value? It is a very direct question which we already discussed in the classrooms, also in the online and offline also there. Here in the workbook also this question is there. what it is, the thing is very simply we should multiply the mod values only. And here you may get a doubt, sir, what about the counters, whether those are synchronous counters or asynchronous counter, otherwise ring counters, in that also different types also there, no sir, you may have a doubt like that. No need to think about all such type of things here, about what type of counter it is actually. Simply whatever be the type of the counters here, but when they are giving here the cascaded way the counters are present here, then you should have the total mod value further, the multiplication of these two mod values only we should do that. So here I think you got the answer very easily, no? Yes, mod 2 followed by mod 5, like that the counter when it is present here, simply we can say that it will be the mod 2 into 5, 10. So the resultant mod value will be the mod 10 counter only. So that by seeing itself we are able to say the answer for this one, isn't it? So here one counter it is given, like that it is, say for example mod 2 in the question, and here this is of mod 5. Then for the overall what will be the mod value if they are asking, then the overall mod value will be mod 2 into 5, that is nothing but mod 10 counter. So this much simply the question was actually asked. It is so simple question. This topic comes under the category of cascaded counters. So in the case of the cascaded counters, when the counters are cascaded, not only two, number of counters when they cascaded, but here in this question they gave two counters, and those two counters of one is mod 2, another is mod 5. So the resultant mod value will be mod 2 into 5, mod 10 counter is the answer. I think you got it, no? Yes, it is already in our workbook also it is there, that type of model question. That question is in sequential circuits. 7th question is this type of question only, which we already solved in our workbook solutions time, isn't it? Are you able to remember? Right. Now we will see then another question here. See, this is one more question here. See here, the maximum clock frequency in megahertz of a 4-stage ripple counter utilizing flip-flop with flip-flop having propagation delay of 20 nanoseconds. Here this question is related to the delay related problem. Actually it is expected that delay related questions in these days we are getting every year almost. In this case, first we have to focus there whether it is the synchronous counter or asynchronous counter. Of course here this is asynchronous counter category only, because ripple counter or that is nothing but asynchronous counter category only. So in this one they gave 4 flip-flops here, 4 flip-flops, that to ripple counter. So each flip-flop when it is having a particular propagation delay of Tp, say for example here each flip-flop is having for example propagation delay Tp, then here n number of flip-flops if it is, then we can say n into Tp is the overall propagation delay we can say. Here n number means here 4 flip-flops already they gave, so that we can say here that is n is here they gave 4 flip-flops, and here each flip-flop is having 20 nanoseconds, so that 20 nanoseconds we can say here. This is nothing but total time period of the clock pulse we required to operate this one. But they are asking the frequency, means so simple, frequency is nothing but 1 by time period. Based on that you can make it and we can get that solution for that one. So it is so simply like that the question. Another one also asked like this. Here this time 2 questions also sequential circuits, that too counter related questions they asked. And these 2 questions also, this question is also there in our MEDISI workbook, that is this model question is in sequential circuit, 11th question in the sequential circuit workbook chapter you can see that, and already we solved that in the workbook solutions time. So it is so simple now, Chintu. We got 4 into 20 nanoseconds is a time period and frequency will be 1 by time period. And previous question also observed like it is nothing but cascaded counters type. Really you can enjoy while solving these two questions. Very simple, and it will give very much happiness also while you are solving the questions also there. Really I think you enjoyed the session and you already enjoyed the exam also, because as far as the digital electronics is concerned, so simple and joyful questions they get asked, that means you are going to get very much joyfulness while solving the questions. Okay, right. Thank you.
Hello everyone, good evening. Let's take up control system questions, GATE 2022 control system questions, and let's see its solutions. I think around 6 questions came from control system, roughly in weightage of 10 to 11 marks. Questions were, except one question, all other questions were very easy. One question of Nyquist, a bit logical, where we need to apply our thinking in a logical manner to answer to that. But overall, it was on easier side. So let's take up the questions of control system and see its solutions. The question came like this: a causal LTS system having the differential equation is given, where x of t and y of t happens to be the input and output respectively. Then what will be the impulse response of the system? Finding the transfer function y of s upon x of s to be 2 upon s by 4 plus 1 can be written as 8 upon s plus 4. The impulse response happens to be inverse Laplace transform of the transfer function 8 e to the power minus 4t u of t. This is the simple answer to this question. So let's move to the next question. Block diagram representation of a system is given. The question is to find the value of omega n and zeta. I think it's given for 2 marks, but that's too much of weightage. But still, it's a very easy question. It's an inner feedback loop with unity feedback in series with this. For that, this is feedback. For that, this is in series. Finally, feedback. The closed loop transfer function C by R of this system can be obtained as 100 upon S square plus 10S plus 100. Right? I write it. 100 upon S square plus 10S plus 100 is the closed loop transfer function of the system. Finding this inner feedback, multiplying with 10 by s, and then finding the outer feedback. This will be the closed loop transfer function. To find omega n and zeta, the function need not be in standard form, except that the s square coefficient has to be 1. So omega n of the system is 10. 2 zeta omega n is 5. So zeta becomes 5 by 10, 0.5. So the answer, it is omega n 10 and zeta 0.5. The answer happens to be option D. Moving to the next question. Open loop transfer function of a system having unity negative feedback is given. Question is to find the range of values of k for the closed loop system to be stable. It's a very simple question, second order system. It is mentioned that feedback is negative, hence the open loop gain k, it has to be positive. Forming the characteristic equation of this system, it becomes s square plus 2s plus k minus 5 is equal to 0. It's a second order system. Necessary condition itself is a sufficient condition. And the necessary here, which is as well as sufficient, is k has to be greater than 5. So k greater than 0 as far as the negative feedback, k greater than 5, final answer is k greater than 5. So that is very much present in the option as option D, k greater than 5 is the answer to the question. Moving to the next question. Nyquist contour of a system is given and the open loop transfer function of the system is also given. The question is to find how many number of times the Nyquist plot will encircle the reference point -1, 0. Let us take this by default in the clockwise direction, taking this to be the default direction, which is clockwise as we usually take, because the direction, it's not mentioned here, but let it to be clockwise. You know what is strange in this question? The direction of this part of the Nyquist contour, which is to bypass the pole at origin, this function has a pole at origin and a pole in the left side of exponent at -1. We know that for this part of the Nyquist contour we get polar plot when it is mapped into the Nyquist plot, and for this we get it to be the mirror image of the polar plot. Whereas this part of the Nyquist contour will suppress or will become a point. These things are very clear. This part of the Nyquist contour will become polar plot in the Nyquist plot. This part of the Nyquist contour will become a point in the Nyquist plot, and this part of the Nyquist contour will become the mirror image of the polar plot with respect to real axis with change in the arrow direction. What about this? We usually take it to be this way. This is the usual direction of the Nyquist contour that we consider. If it is this, then P stands for the number of poles of the given function that are encircled by the Nyquist contour is 0 if it is this. But in the question it is given to be this. So P is equal to 0 should not be considered. P is equals to 1. So don't mistake P as the number of open loop poles in the right side of S-plane. The basic definition of P happens to be the number of poles of the given function that are encircled by the Nyquist contour. Suppose if this is the Nyquist contour as we usually take, then P stands for number of open loop poles in the right side of S-plane, which will be 0. But if this is the Nyquist contour, then P stands for not the number of open loop holes in the right side, it happens to be the number of open loop holes that are encircled by the Nyquist contour. So P becomes 1. Fine. Now suppose if you obtain the Nyquist plot of this system, which is really not required, from the stability we can check. See, if it is P is equal to 1, it's a second order system which is by default stable. Standard first and second order systems are stable systems. According to Nyquist, if system has to be stable, that means N is equals to P. P is anyhow 1, so N has to be 1. That is the answer to the question. Or if you obtain the Nyquist plot of the system, this happens to be the polar plot which corresponds to this part of the Nyquist contour, and this will be the mirror image of the polar plot with respect to real axis with opposite direction, corresponding to this part of the Nyquist contour. Corresponding to this part of the Nyquist contour, this will be the Nyquist plot. Now corresponding to this part of the Nyquist contour, this will be the Nyquist plot. So -1 is somewhere here. You know why? Because here for this part of the Nyquist contour, the phase angle is considered to be -90 to -180 to -270. Now when it is mapped into the function, the phase of the function becomes -θ with magnitude infinity. So when it is -θ, it is +90 to +180 to +270. So this is +90, 0, 90, 90, 180, 270. So it will be like this. So -1 is encircled once in anti-clockwise direction. You can still call N to be 1. But that's really not required to go to Nyquist plot. We can still convince from here. The only thing you need to understand is by default P stands for poles of the function that are encircled with the Nyquist contour. So if the Nyquist contour is defined to be like this, it is this. Remember, the Nyquist contour should not pass through any poles of the given function. Otherwise, we cannot get the Nyquist plot. So to bypass the pole or poles at origin, either we take the Nyquist contour in this way or we take the Nyquist contour in this way. Either way, it is the same thing. But definition of P, you should be focused. Now, coming to this question, the board plot of a first order system is given. It is mentioned that the system is first order. The question is, the above system has got how many zeros and how many poles? It's a question based on the statements, statement wise question. See, order is 1. It means number of poles are 1. Order, it is mentioned that order is 1. So number of poles have to be 1. So what about zeros, sir? Suppose if there is no 0, then this magnitude plot cannot be constant. The peculiarity is the magnitude plot. If the magnitude plot of a system is constant, it means it is all pass. And all pass will have equal number of poles and zeros such that they are mirror image of each other with respect to j omega axis. So if there is a pole, then there is a 0 as well. Right, it is this or 1 minus s by 1 plus s. So it has to be all pass. So this has one pole and one 0. That has to be the answer to the question. Now coming to the last question. Question is to find the values of A and B. This input is a composite one. It has got two components. One is DC, another is a sinusoid of frequency say 10. Now corresponding to this input, what is output? Yeah, output is this. This is the magnitude of the output for this input. This is the magnitude of the output for this input. So we have an equation that B is equal to A mod G of j omega. A happens to be input amplitude and B happens to be output amplitude. This is magnitude of the transfer function. Since the frequency of this component of the input is 0, we have to simply find this B as input amplitude 1 multiplied by the 0 frequency magnitude of this function, which will be simply 1. So this we are calling it to be A value, which is 1. Now coming to the small b value, which happens to be product of the input amplitude and magnitude of the transfer function. 100 upon 100 minus omega square plus 0.1 j omega for omega is equal to 10, the frequency of this component. So this comes out to be, since omega is 10, omega square is 100, these two gets cancelled. Now omega is 10, 0.1 into 10 is 1, so this factor is 1. The magnitude happens to be at omega is equal to 10, right? So this term becomes 1. So it is 100 into 0.1, it has to be 10. So I mean, of course, some options are taken to be not properly. So according to the calculations and according to the data based on the memory, A is 1 and B is 10 is what I actually consider the answer to be. So that's all about it. So in very less time, like of 6 questions of weightage of 10 to 11 marks, you might have definitely solved this. With explanation it took time, otherwise without explanation it would have been a matter of hardly 5-6 minutes. So the test series and all other explanations that we have discussed in the class must have benefited to you. So that's about it. Wish you all the best for the results to come. Thank you.
So hello everybody, this is Rajan Roy and we are going to discuss electrical machine portion, correct? Myself and with me Roshan sir is also there. So now in electrical machine, right? In electrical machine, questions are from a DC machine, synchronous machine and induction machine. There are no transformer questions as far as till now whatever questions we have got, correct? So now in DC machine, the same question already GTQ in GTQ in class also we generally teach this, but in GTQ also, if you have attended that GTQ, the same questions we have discussed, same that speed control and that torque relation and all. So first of all in that question, what we can see two parts are there generally. What they are asking, a speed, right? A speed in RPM, correct? See here, a speed in RPM, right? So a speed in RPM is there, DC motor is there, or DC machine is there, correct? So just I have told you, if you can remember, only two equations, right? If you can remember only two equations, EB is equal to K phi omega and torque is equal to K phi Ia, right? So in that relation also, as a speed is asked, so first of all what we have to focus? We have to focus on a speed, correct? So a speed is related to EB. ये चीज तो दिख रही है clearly? Yes or no? Yes sir. तो पहले उधर से सोचते हैं और फिर जब हमें सपोज ऐसा लगता है कि unknowns are more, तो फिर हम इसका भी हेल्प लेंगे, करेक्ट? तो सेपरेटली एक्साइटेड मशीन है, यस सर, तो सेपरेटली एक्साइटेड मींस फ्लक्स क्या होगा? तो सर फ्लक्स तो कांस्टेंट रहेगा, करेक्ट? अब इसमें ऑफ कोर्स ईबी एंड ओमेगा इज देयर ना, ईबी और स्पीड इज देयर ना, यस सर। तो इसका मतलब ये है कि टू अननोन्स आर देयर, दैट मींस एटलीस्ट टू कंडीशंस विल बी देयर, यस सर। तो इस क्वेश्चन में व्हाट वी कैन सी, देखिए 280 वोल्ट सेपरेटली एक्साइटेड डीसी मोटर with armature resistance this much and constant field excitation drives a load torque is proportional to a speed. This data is also given, correct? This data is also given, जो load torque है proportional to a speed, ये given है, this is given in the problem, right? This is given in the problem. और हम लोग क्या जानते हैं? तो सर टॉर्क इज प्रोपोर्शनल टू IA बिकॉज फ्लक्स कांस्टेंट है, सेपरेटली एक्साइटेड, ओके फाइन। तो दिस इज गिवन, yes sir, and this already we know that if there is a need we can use this also, right? ये साइड में है, अच्छा सर। then they are asking the motor draws a current of 30 ampere running at a speed of 1000 rpm। यानी पहला कंडीशन क्या दे दिया? जब वो मोटर आर्मेचर करंट 30 एम्पियर ले रहा है, हाँ जी सर, तो फिर उस टाइम में जो उसकी स्पीड है, दैट स्पीड इज 1000 rpm, करेक्ट? यानी पहला कंडीशन। अच्छा, फिर पूछ रहा है कि फ्रिक्शन लॉस वगैरह इग्नोर करिए, एंड व्हाट विल बी ए स्पीड व्हेन एडिशनल रेजिस्टेंस ऑफ दिस मच इज कनेक्टेड इन सीरीज। तो अब नेक्स्ट टाइम में, तो पहला इस कंडीशन से हम क्या देखते हैं? एज वी नो दैट स्पीड रिलेशन है, स्पीड पूछ रहा है, हाँ जी सर, तो कहीं ना कहीं दिस इज इंपॉर्टेंट फॉर अस, यस सर। तो नाउ माय डियर फ्रेंड, पहले इस कंडीशन को यूज कर लेते हैं। व्हाट इज दिस सपोज अगर मान लीजिए EV1 बोल देता हूं, क्या हो जाएगा? कितना है? 280 वोल्ट है ना, दैट इज हाउ मच इट इज? 280 वोल्ट। तो क्या लिख सकते हैं? वी कैन राइट हियर 280 माइनस, राइट, माइनस IA कितना एम्पियर है? 30 इंटू RA कितना है? दैट RA इज 1 एम्पियर, राइट, 1 एम्पियर, राइट। सो दिस इज 1 एम्पियर। सो दिस इज योर फर्स्ट EB1 जिसको हम बोलते हैं, एंड इट इज प्रोपोर्शनल टू 1000 rpm। क्लियर है? इक्वेशन नंबर 1। अब दूसरे इक्वेशन में व्हेन वी हैव एडेड सम एक्सटर्नल रेसिस्टेंस, यस और नो? सो एक्सटर्नल रेसिस्टेंस मींस 280 तो ऐसा ही रहेगा, करेक्ट, माइनस, अब करंट के बारे में तो कुछ बोला नहीं इधर, तो चलो करंट को हम वैसे ही रखते हैं, करेक्ट। इन GTQ आल्सो इफ यू कैन सी, आई थिंक क्वेश्चन नंबर 3, राइट, कुछ ऐसा ही क्वेश्चन था एक। तो इंटू 1 प्लस कितना एक्सटर्नल रेसिस्टेंस ऐड किया, दैट इज गिवन, राइट? कितना ऐड किया? 10 ओम, ओके फाइन। तो 1 प्लस इसको 10 कर लेते हैं। अच्छा, सो दिस राइट इज प्रोपोर्शनल टू n, और यह n क्या है? अननोन है। चलो एक काम करते हैं, इसको n2 कर देते हैं, इक्वेशन नंबर 2। सो व्हाट वी कैन सी, इफ दिस इज आल्सो नोन, तब तो सीधे 1/2 कर देते हैं ना, डायरेक्ट 1/2 करके वी कैन हैव आवर आंसर, बट दिस इज आल्सो अननोन ना, यस सर। तो अब ये किधर से आएगा? तो नाउ जब हमारा रास्ता इधर बंद हो जाता है, देन वी हैव टू सर्च दिस करंट, और करंट का रिलेशन किसके साथ है? टॉर्क के साथ है। क्या रिलेशन है? तो टॉर्क इज प्रोपोर्शनल टू n, इट इज गिवन, yes sir, and torque is proportional to IA, actually we know, है ना? ये चीज तो हमें पता होती है रिलेशन से. सो दिस इज गिवन एंड दिस इज नोन. यस और नो? यस. सो व्हाट वी कैन रिलेट फ्रॉम हियर? n इज प्रोपोर्शनल टू IA. Yes sir. So what we can see, n1 by n2 is equal to I1 by IA2. Clear है? Yes sir. So from here we can have relation between n and I. Right? So 1, 2 and this is our third equation. So now with the help of these three equation we can have our value of n2 और वो n2 कितना आ जा रहा है? 482.75. तो 1, 2, 3 से 1, 2 और 3 से जब हम सॉल्व करते हैं तो n2 आ जाता है. दैट n2 इज 482.75. 482.75 RPM. राइट? सिंपल है, कुछ ज्यादा मुश्किल नहीं है. ये क्लास में भी होता है ना, सॉल्व करते ही हैं, और GTQ में भी अभी भी कराया था. करेक्ट? अच्छा, नेक्स्ट आ जाइए. नेक्स्ट क्वेश्चन इज रिलेटेड टू योर सिंक्रोनस मशीन. This is classroom note question, correct? You can see in notes also. But anyway, ठीक है. पहले मैं इसको क्या करता हूँ, डायग्राम से थोड़ा आपको बताता हूँ ये क्या दिया हुआ है ना. बहुत ही सिंपल क्वेश्चन है. And whenever power flow is there, try to draw the diagram. Always I suggest you, right? Yes or no? Yes sir. तो मान लीजिए सपोज ये हमारा मोटर है और इन दिस मोटर दे हैव इग्नोर्ड RA. चलिए RA को इग्नोर कर देते हैं. इधर लाइन वोल्टेज इज गिवन, दैट इज आई थिंक 400. कितना दे रखा है? दैट इज दैट लाइन, यस 400. तो ये कितना हो जाएगा? 400 बाय √3. यस और नो? यस सर. एंड दैट पावर इज गिवन. करेक्ट? मान लीजिए सपोज, राइट, दिस इज योर शाफ्ट एंड तो इधर का पावर दे रखा है. कितना दे रखा है? दैट पावर इज 10 किलोवाट. 10 किलोवाट. करेक्ट? और लॉसेस आर आल्सो गिवन, दैट इज 2 किलोवाट. इधर का लॉसेस कितना दे रखा है? 2 kilowatt, because RA is not there. Yes or no? If RA is not there, that losses is here only, right? So now my dear friend, what we need to calculate? We need to calculate this EF value per phase value, right? EF per phase कितना होगा? This data is given, correct? अच्छा, तो first of all data is given from this side, so we need to reach from here to here first of all. ठीक बात है, यहां से यहां जाना होता है, तभी तो आप इसके बारे में सर्च आउट करोगे. यस सर. तो सीधी सी बात है, इधर से इधर अगर हम जाते हैं, राइट, हाँ जी सर, तो ये पावर कितना हो जाएगा? व्हाट इज योर डेवलप्ड पावर? व्हाट वी कैन से, तो कितना आ जा रहा है? पावर डेवलप्ड, करेक्ट? कितना आ रहा है ये? 10 + 2 यानी कि 12 किलोवाट ना, किलोवाट. राइट? अच्छा सर, तो अब जब ये 12 किलोवाट आ चुका है, यस और नो? यस. तो नाउ वी नो दैट EF क्या होता है? EF क्या होता है ये तो पता है ना? यस सर. EF इज इक्वल टू V माइनस JIA/XS. यस और नो? यस सर. मोटर है ना? हाँ जी सर. ठीक है, क्लियर है? यस सर. KVL लगा दिया. तो इसमें V is given, that is 400 by √3 एंगल 0. यस और नो? यस सर. अब आ जाइए माइनस J, करेक्ट, IA एंगल, और लीडिंग है तो cos इनवर्स 0.8 लीडिंग दे रखा है, करेक्ट, और इनटू एक्सेस की वैल्यू कितनी है? दैट इज 1 ना, 1. सिंपल ये रिलेशन है. दिस इज योर EF, बट हियर IA is also unknown na? Yes sir. So what we can do? We can relate this formula. Here developed power already we know and there is no losses. यहाँ पे कोई लॉस नहीं है, करेक्ट? आप क्लासरूम नोट्स में भी देखोगे एग्जैक्टली यही क्वेश्चन है, राइट? बस डेटा में भी थोड़ा सा चेंज होगा, बट यही है, राइट? तो इधर अगर पावर नहीं दिया हो तो हम क्या करते हैं? ये दोनों पावर को सेम ले लेते हैं, करेक्ट? तो P developed is equal to P input, because RA is not given, so that is why we are ignoring this, correct? तो ये कितना आ जा रहा है? That is 12 kilowatt, 12 into 10 to the power 3 divided by √3 VI cos 5. क्लियर है? हाँ जी सर. तो now my dear student, from here what is I? तो I value is 21.65 एम्पियर. ठीक बात है? हाँ जी सर. Once we got I या IA बोल दीजिए इसको, राइट? तो फिर हम ये वैल्यू इधर पुट कर देंगे. हाँ जी सर. और ये पुट करने के बाद आवर आंसर इज कितना आ रहा है? दैट वैल्यू इज ऑलमोस्ट 244.5 वोल्ट. करेक्ट? मॉड लिख रहा हूं और एंगल भी आएगा. ठीक है, क्लियर है? So that's it from DC and synchronous portion. Now for induction portion, correct? I request Roshan sir, and please come and explain. Thank you so much.
Welcome everyone. So I'm going to discuss induction machine part from electrical machine. And remember, these questions are memory based, so there may be change in data. इसको आप बस ध्यान में रखिएगा. But we have these questions from induction machine. In this question it is saying that 3-phase 415 volt 50 hertz induction machine draws 5 times the rated current at rated voltage at starting. It is required to bring down the starting current from the supply to 2 times of rated current using a 3-phase auto transformation. Neglect all losses. Find transformer ratio of auto transformer. सो हमेशा याद रखिए जब हम लोग स्क्वायरल केज इंडक्शन मोटर की बात करते हैं, सो वी आर यूजिंग दिस ऑटो ट्रांसफार्मर मेथड, स्टार डेल्टा मेथड, डीओएल मेथड, स्टेटर रेजिस्टेंस रिएक्टेंस मेथड. क्लास में हमने इस तरह के क्वेश्चंस, कई सारे क्वेश्चंस इस तरीके से हमने डील किया हुआ है जो कि स्क्वायरल केज के स्टार्टिंग मेथड्स पे था. सो दिस इज वेरी सिंपल क्वेश्चन. Here we have given that starting current is 5 times. Starting current is 5 times of rated current. So we know that starting current is ISC. It is 5 times of IFL. We are saying that it is at the condition of DOL, isn't it? What is the meaning of DOL? DOL means you just can say that at rated voltage. Means at rated voltage at starting we have this much of a starting current. Fine. Now we need to use auto transformer to reduce or to suppress or to control the starting current. Actually we use starting methods in induction machine to control the starting current, isn't it? So when we use auto transformer, starting current become x squared times of ISC, and in this question it is given that it is 2 times of full load current. This is in auto transformer method. Very simple question it is. And what is x here? X is auto transformer ratio. So transformation ratio is fine. So just put ISC from here to here. So I'm saying that this is equation 1 and this is equation 2. So from 1 and 2, we can write x square into ISC. What is ISC? ISC is 5 times of IFL. So 5 times of IFL, which is equal to 2 into IFL. So IFL cancel. X square become 2 by 5 or 0.4. So what we get? X become under root 0.4. So when you calculate it, it is 0.6324. You can observe here it is asking that you have to find transformation ratio of auto transformer. अगर ये डेटा सही है, so this will be the answer. लेकिन कई बार क्वेश्चन में इन परसेंटेज, कई बार इसी ट्रांसफार्मर रेशियो को पूछ दिया जाता है इन परसेंटेज. सो अगर इस क्वेश्चन में परसेंटेज, जहां तक मेमोरी बेस्ड क्वेश्चन है और जहां तक हमें डेटा मिला है उसमें ये ऑटो ट्रांसफार्मर रेशियो पूछा गया है. सो आवर आंसर विल बी दिस ओनली. लेकिन इसी को परसेंटेज में अगर पूछा गया होगा, सो आंसर विल बी 63.24%. अगर परसेंटेज में नहीं पूछा जा रहा है, सो दिस इज आवर आंसर. फाइन. नाउ नेक्स्ट वन. This is very simple question. The frequencies of stator rotor currents flowing in 3 phase, P is 8, number of poles is 8, induction motor are 40 hertz and 1 hertz respectively. The motor speed in RPM. So this is very simple question. Here we have stator and rotor induced frequency. So let us assume here we have a stator supply. The stator frequency is 40 hertz. So I'm assuming that supply frequency is 40 hertz, and in this question it is given that at rotor induced frequency is 1 hertz, isn't it? And we know that Fr is equal to slip times of Fs, isn't it? In induction machine we know that rotor induced frequency becomes slip times of stator frequency. Here it is given 1 hertz, slip into 40. So what we get? Slip we are getting 1 by 40, isn't it? Now we need to find motor speed in RPM. Correct? We know that nr is equal to 1 minus s into ns. So we got this slip. So if we have ns, we can get nr. So ns become, it is 40 hertz, supply frequency 40 hertz, number of poles is 8. So ns is 120 f upon p. So 120 into 40 by 8. So you will have 600 RPM, isn't it? So just put here. So NR become 1 minus S, S we have calculated 1 by 40 into 600. So when you solve this, you will have 585 width. It is 585 RPM. Correct? Now, next question is the type of, this is theoretical question, the type of single phase induction motor expected to have the maximum power factor during steady state running condition. We know that we use capacitor start, capacitor run motor to improve the power factor at running condition. एक्चुअली दिस कैपेसिटर स्टार्ट, यहाँ पे जो कैपेसिटर हम लोग यूज कर रहे हैं, ये हम लोग यूज कर रहे होते हैं स्टार्टिंग टॉर्क के लिए कि हमें हायर स्टार्टिंग टॉर्क मिले, जबकि कैपेसिटर स्टार्ट कैपेसिटर रन ये जो कैपेसिटर है, दिस कैपेसिटर हेल्प्स टू इंप्रूव पावर फैक्टर एट रनिंग कंडीशन. सो आंसर विल बी दिस, कैपेसिटर स्टार्ट एंड कैपेसिटर रन. सो ओके, थैंक यू. वी हैव these questions from इंडक्शन मशीन, डीसी और सिंक्रोनस मशीन सर ने डिस्कस कर लिया है. ओके, थैंक यू वेरी मच.
Hello everyone, myself Rohit Kumar Tripathi. So me and Naveen sir, we are going to discuss some questions of signal and system. So let us see what are the questions in GATE 2022. तो फर्स्ट क्वेश्चन में सिस्टम का इनपुट गिवन है, इनपुट में इनपुट साइनसोइडल कंपोनेंट्स का सम है और इसे अप्लाई करना है एलटीआई सिस्टम पर. एलटीआई सिस्टम का इम्पल्स रेस्पॉन्स गिवन है और आउटपुट कैलकुलेट करना है. और ओके ठीक है, तो इसमें एक काम करते हैं, इसे इस तरह सॉल्व करते हैं. सबसे पहले क्या करना चाहिए, वी शुड फाइंड आउट ट्रांसफर फंक्शन ऑफ सिस्टम, सो दैट कि ट्रांसफर फंक्शन कैलकुलेट करने के बाद पता चले कि ट्रांसफर फंक्शन सिस्टम का लो पास, हाई पास, बैंड स्टॉप किस टाइप का है. एंड डिपेंडिंग अपॉन दैट हम ये डिसाइड कर सकते हैं इजीली कि इनपुट में ये जो फ्रीक्वेंसी कंपोनेंट्स हैं, इनमें से कौन कौन सा फ्रीक्वेंसी कंपोनेंट पास होगा. सो लेट अस फाइंड आउट सिस्टम ट्रांसफर फंक्शन. तो सबसे पहले इम्पल्स रेस्पॉन्स को थोड़ा सिंप्लीफाई करते हैं. इसे इस फॉर्म में लिखता हूँ, साइन 10 पाई टी अपॉन पाई टी है तो इसे मैं 10 पाई टी ऐसे लिख देता हूँ, इसे मल्टीप्लाई कर दूंगा 10 से. ओके ठीक है, इसे प्रीवियस फॉर्म में ही रहने देता हूँ. हाँ, ज़्यादा ही इस तरह होगा कि 2 साइन ए कॉस बी का फॉर्म है, तो 2 साइन ए कॉस बी है तो हम लोग इसे साइन ए प्लस बी प्लस साइन ए माइनस बी के फॉर्म में लिखेंगे. और अगर यहाँ पर देखें तो कॉस वाले टर्म में फ्रीक्वेंसी ज़्यादा है तो फिर इसे साइन ए प्लस बी माइनस साइन ए माइनस बी के फॉर्म में लिखेंगे. तो इसे इस फॉर्म में लिखो आप, साइन ए प्लस बी तो a प्लस बी कितना होगा, साइन 50 पाई टी माइनस साइन a माइनस बी। a माइनस बी आप चेक करोगे तो कितना होगा, 40 पाई माइनस 10 पाई कितना, 30 पाई टी डिवाइडेड बाय हाउ मच, पाई टी। तो अब इसे आप इस फॉर्म में लिखो, इसे आप सेपरेटली पाई टी से डिवाइड कर दो, तो आप इसे इस फॉर्म में लिखते साइन 50 पाई टी अपॉन पाई टी माइनस साइन 30 पाई टी अपॉन पाई टी, इस फॉर्म में लिखूंगा। ओके, नाउ लेट अस अज्यूम फर्स्ट टर्म इज h1t एंड सेकेंड टर्म इज h2t। ओके, अब आप इस पर क्या अप्लाई करो, फूरियर ट्रांसफॉर्म। सो h ऑफ ओमेगा, व्हाट इज h ऑफ ओमेगा, h ऑफ ओमेगा इज ट्रांसफर फंक्शन ऑफ सिस्टम। So h of omega will be equal to h1 omega minus h2 omega. Okay. अब h1 ओमेगा h2 ओमेगा ड्रॉ करना है, ड्रॉ करने के बाद दोनों को सबट्रैक्ट करना है, सबट्रैक्ट आप करोगे तो रिजल्टेंट ट्रांसफर फंक्शन h ऑफ ओमेगा मिलेगा। सो लेट अस ड्रॉ h ऑफ ओमेगा विथ रिस्पेक्ट टू h1 ओमेगा with respect to omega. Then what we have to draw, we have to draw h2 omega with respect to omega. Then what we have to draw, we have to draw their subtraction. It means h of omega with respect to omega. Okay, तो h1t sin 50 पाई टी अपॉन पाई टी है। जब आप इसका ट्रांसफर फंक्शन और फोरियर ट्रांसफॉर्म ड्रॉ करेंगे तो रेक्टेंगुलर पल्स आएगा, रेक्टेंगल का एक्सटेंशन माइनस 50 पाई से 50 पाई के रेंज में होगा। तो इट मीन्स h1 ओमेगा में क्या ड्रॉ करूंगा, रेक्टेंगल, एक्सटेंशन माइनस 50 पाई टू 50 पाई एंड पल्स एम्पलीट्यूड इज हाउ मच, 1। सिमिलरली h2t यहाँ पर ये वाला टर्म है। अब अगर आप इसका फोरियर ट्रांसफॉर्म ड्रॉ करेंगे दैट विल बी h2 ओमेगा, तो h2 ओमेगा में क्या मिलेगा, अगेन रेक्टेंगल, एक्सटेंशन माइनस 30 पाई से कहां तक, 30 पाई तक, पल्स एम्पलीट्यूड कितना, 1। अब दोनों को क्या करना है, सबट्रैक्ट, इन दोनों को आप सबट्रैक्ट करेंगे तो सबट्रैक्शन में रेक्टेंगुलर पल्सेस मिलेंगे, दोनों का एम्पलीट्यूड कितना, 1, और एक्सटेंशन LHS में माइनस 50 पाई टू माइनस 30 पाई, RHS में 30 पाई टू 50 पाई। अब अगर आप देखें तो ये ओवरऑल ट्रांसफर फंक्शन है सिस्टम का। तो ये जो ट्रांसफर फंक्शन है किस टाइप के फिल्टर का है, बैंड पास फिल्टर का है। अब इस बैंड पास फिल्टर में लोअर कट ऑफ फ्रीक्वेंसी कितनी है, 30 पाई, हायर कट ऑफ फ्रीक्वेंसी कितनी है, 50 पाई। अब सिस्टम उन्हीं फ्रीक्वेंसी कंपोनेंट्स को पास करेगा जो इस फ्रीक्वेंसी रेंज में लाई करेगा, मतलब 30 पाई टू 55 के रेंज में। तो फटाफट हम लोग देखते हैं कि इनपुट में कौन कौन से फ्रीक्वेंसी कंपोनेंट्स हैं जो 30 पाई टू 50 पाई के रेंज में है। तो यहाँ पर अगर आप देखें तो 10 पाई है, ये सिस्टम से पास नहीं होगा। अगर आप देखें यहाँ फ्रीक्वेंसी है 15 पाई, ये भी सिस्टम से पास नहीं होगा। इसकी फ्रीक्वेंसी कितनी है, 42 पाई, सो इट इज लाइंग बिटवीन 30 पाई एंड 50 पाई, सो इट विल बी पास्ड बाय सिस्टम। और जो लास्ट वाला कंपोनेंट है इसकी फ्रीक्वेंसी कितनी है, 45 पाई, अगेन ये 30 पाई से 50 पाई के बीच में है, तो ये भी सिस्टम से पास होगा। तो ये दो कंपोनेंट्स सिस्टम से पास होंगे, इसका मतलब सिस्टम का आउटपुट होना चाहिए 7 sin 42 पाई टी प्लस 4 cos 45 पाई टी। तो फटाफट मैं सिस्टम का आउटपुट लिख देता हूं। सो व्हाट इज सिस्टम आउटपुट, सो सिस्टम आउटपुट इज बाई टी एंड इट विल बी इक्वल टू हाउ मच, इट विल बी इक्वल टू 7 sin 42 पाई टी, 7 sin 42 पाई टी, 7 sin 42 पाई टी। एक और कंपोनेंट है मेरे दोस्तों, क्या है फटाफट देखें, 4 cos 45 पाई टी। ओके, 4 cos 45 पाई टी, ठीक है। अब थोड़ा क्रॉस चेक करते हैं, आप भी चेक कीजिए कि कौन सा ऑप्शन मैच होगा। तो 42 पाई और 45 पाई दो फ्रीक्वेंसी कंपोनेंट्स हैं, इन सब में आप चेक करें तो 42 पाई एंड 45 पाई, इसका मतलब कौन सा ऑप्शन आंसर है, आंसर है ऑप्शन ए, ठीक है। तो अभी कुछ और भी क्वेश्चंस हैं, फटाफट नवीन सर अभी कुछ और क्वेश्चन डिस्कस करेंगे, अगेन मैं वापस आऊंगा और कुछ और क्वेश्चन डिस्कस करूंगा सिग्नल सिस्टम के।
Hello everyone, you can see about the next question. So next question is given as x of t is equal to applied to a system where the relation between the input and output is given as y of t is equal to x of e to the power of t, and he was asking that the system is linear and causal, nonlinear and causal, nonlinear and non-causal, and linear and non-causal. So now we are going to solving this question. So we need to find about the linearity. So we know that for linearity, we will know that such that so y of t is equal to x of e to the power of t is given. So we know that for linearity it has to be satisfies the superposition theorem. So for superposition theorem we know that it is nothing but an combination of two theorems. One is called as additivity and another one is said to be called as scaling, also called as homogeneity. If you see here directly, y of t is equal to x of e to the power of t, operation is performing on the time. That means there is no change in the amplitude. We can tell directly this system was said to be called as linear system. That is, system is linear. We can tell such that your system is going to be linear. With a linear system we are having. Because operation is performing on the time, so there is no change in the amplitude. Even if substituted also, we get the additivity and scaling both will be satisfied. So next one is, you are asking about the causal condition. If you write about the causal condition, system is said to be causal if it depends only on the present values and on the past values, but not on the future values. So it does not depend upon the future values. Now we can see that given y of t is equal to x of e to the power of t. If I take the value of t is equal to 0, that means y of 0, this is nothing but an your present output value, and we substitute that x of e to the power of 0, that is equal to x of 1. The present output is depending upon the future value of the input. Therefore, system is said to be called as a non-causal. That means it is linear by observing the superposition theorem, and it is said to be called as the non-causal system. If you check the options, in the options we can going to be find out. So in the option we can find out so it will become as a non-linear and it will become as linear and non-causal. That means option D is the answer we are having. So if you check that option D is the answer. So option D, which is given as a linear and non-causal, we are having. So next question we will see about the another one. So let a causal LTI system be governed by the following differential equation: y of t plus 1 by 4 dy by dt is equal to 2 into x of t, where x of t and y of t are input and output respectively. The impulse response he was asking. So here is a differential equation. From that you have to find the impulse response. So if you see that solution for this question, so the given one is y of t plus 1 by 4 dy of t divided by dt is equal to x of t. So that is the given equation. If you see that y of t plus 1 by 4 dy of t by dt is equal to 2 into x of t is given. So we have to write about the equation that is equal to that of 2 into x of t. So 2 into x of t. Now we can apply the Laplace transform. So whenever we are applying the Laplace transform, so is equal to that of y of s plus 1 by 4 into s into y of s is equal to 2 into x of s. So after applying the Laplace transform, we can write this value y of s that is equal to 1 plus s by 4 is equal to 2 into x of s. So transfer function, so y of s divided by x of s we are having, and that is given as 2 upon 1 plus s by 4. The resultant equation is equal to 8 divided by s plus 4. We observe in the question we need to find the impulse response. If you see that impulse response he was asking in the question, so we need to apply the Laplace transform. So before applying the Laplace transform, in the question also we specified it is the causal LTI system. Because of causal LTI system, we need to consider the respective inverse Laplace transform must be the right sided, so right sided signal. So we can write like this, applying the inverse Laplace transform. So the equation is written in this way, that is h of s is equal to 8 divided by s plus 4, which is the transfer function. So we apply the Laplace transform, then h of t value is equal to 8 into e to the power of minus 40 into u of t. Because the given is the causal LTI system, we are considering the right sided sequence, that's why writing as 8 into e to the power of minus 40 into u of t. This is the impulse response we are getting for our system. If you check the options, then we understand clearly such that 8 into e to the power of minus 40 into u of t is nothing but an option C. So this is the option C is the answer. Okay. So the remaining questions will taken by the Rohit sir. Thank you.
चलिए मैं तो वापस आ गया, वापस से देखते हैं कि अभी कौन कौन से क्वेश्चंस हैं. ठीक है, तो नेक्स्ट क्वेश्चन है DTFS से रिलेटेड. तो पहले देखते हैं डाटा क्या गिवन है. ओके, तो ये DTFS एक्सपेंशन के फॉर्म में गिवन है. टाइम पीरियड कितना है? टाइम पीरियड ऑफ सिग्नल इज हाउ मच? 3. अब जो सिग्नल का टाइम पीरियड होता है वही टाइम पीरियड किसका होता है? DTFS कोएफिशिएंट का. इट मींस x ऑफ n का कोएफिशिएंट है ak, x ऑफ n का कोएफिशिएंट, x ऑफ n का कोएफिशिएंट क्या है? ak. तो ak का भी टाइम पीरियड कितना होगा? 3 होगा. ओके, ठीक है, थोड़ा और आगे देखते हैं अभी और डाटा क्या है. ओके, ठीक है. अब ak में कुछ सैंपल्स गिवन है. a-3 इज गिवन, a2 इज गिवन एंड a4 इज गिवन. ठीक है, करना क्या है? x ऑफ n को ट्रिग्नोमेट्रिकल फॉर्म में लिखना है. ओके, तो इसको किस तरह सॉल्व करें एक बार देखते हैं. ठीक है, ओके. तो सबसे पहले कुछ सैंपल्स गिवन है. ठीक है, हमने अभी तक क्या देखा? सिंस xn इज पीरियोडिक विथ फंडामेंटल टाइम पीरियड 3 एंड ak एंड x ऑफ n आर पीरियोडिक विथ सेम टाइम पीरियड, सो फॉर ak time period, fundamental time period is also how much? 3. तो AK का भी टाइम पीरियड कितना होगा? 3. It means AK will be equal to AK plus m into n. यहाँ पर स्मॉल n क्या है? स्मॉल m क्या है? इंटीजर. Where small m is an integer. ओके, यहाँ तक ठीक है. कैपिटल N कितना है? 3. तो आप इसे क्या लिखते? AK 3m. यहाँ तक ठीक है. सिंपल वर्ड्स में बताता हूँ. इसका मतलब है कि यहाँ ये जो a-3 है, इसमें आप 3 का कोई भी इंटीजर मल्टीपल ऐड करें, सब्ट्रैक्ट करें, सैंपल वैल्यू सेम ही रहेगा. इट मीन्स जैसे अगर मुझे a0 लिखना है, तो अब a0 के 0 में आप 3 का मल्टीपल ऐड करें, सब्ट्रैक्ट करें, सैंपल वैल्यू सेम ही रहेगा. ओके, तो a0 में आप 3 ऐड करें, 0 में 3 ऐड करें तो कितना आया? a3. तो a0 किसके इक्वल होगा? a3 के इक्वल. ओके, a3 कितना है? a3. ठीक है, हम लोग ऐसा भी कर सकते हैं, a-3 से भी कैलकुलेट कर सकते हैं. ऐसा करता हूं, थोड़ा अपोजिट चलता हूं, अपोजिट. ठीक है, तो वापस से बोलता हूं. ओके, a0 मालूम है. ओके, अब इसके 0 में 3 का कोई भी इंटीजर मल्टीपल सब्ट्रैक्ट करो या ऐड करो, वो a0 के ही बराबर होगा. तो 0 में आप 3 को सब्ट्रैक्ट करो, तो यहाँ पर करेक्शन करना होता और यहाँ पर हम लोग क्या लिखते? ये a-3 के इक्वल होता. तो अब देखते a-3 कितना है. सो व्हाट इज a-3? हाउ मच? इट इज 1. तो a0 कितना आया? 1. अच्छा, अब उसके बाद थोड़ा a1 कैलकुलेट करते हैं. ओके, अब a1 के 1 में 3 का कोई भी इंटीजर मल्टीपल ऐड करो सब्ट्रैक्ट करो वो A1 के बराबर ही होगा। ये कहाँ से मैं बोल रहा हूँ, इस वाले रिलेशनशिप को देख करके बोल रहा हूँ, ठीक है। तो A1 के 1 में 3 का इंटीजर मल्टीपल 3 ऐड कर देता हूँ, तो कितना आया A4, मतलब A1 किसके इक्वल, A4 के इक्वल। A4 कितना है, किधर है किधर है किधर है, देखो A4 कितना है 1, ठीक है। तो A4 कितना आया 1। अब इसके बाद A2, ओके। तो पहले देख लेता हूँ A2 गिवन है क्या डायरेक्टली, यस A2 इज गिवन डायरेक्टली एंड इट इज हाउ मच, इट इज 1, ठीक है। तो आखिर मैंने ये 3 सैंपल्स क्यों कैलकुलेट किए, इसलिए कैलकुलेट किए क्योंकि यहाँ ये जो x ऑफ n गिवन है ये ओवर द रेंज 0 to n-1 है। और अगर आप थोड़ा ध्यान से देखें तो कैपिटल N कितना है, कैपिटल N है 3, तो 3 - 1 विल बी हाउ मच 2। इसका मतलब अगर मुझे एक्सपेंड करके लिखना था तो एक के 3 सैंपल्स चाहिए थे, कौन कौन से, A0, A1 एंड A2। क्यों, क्योंकि आप k को 0, 1 एंड 2 पुट करेंगे, k को 0 से 2 तक पुट करना है, तो यहाँ पर A0, A1, A2 चाहिए था। इसलिए मैंने गिवन डाटा से पहले क्या कैलकुलेट किया, A0, A1 एंड A2। जब तीनों मिल गए तो अब हम लोग एक्सपेंशन को यूज करेंगे और फटाफट लिखेंगे x ऑफ n। तो क्या लिखता, समेशन 0 टू हाउ मच 2, फिर इसके बाद a के, फिर कितना e की पावर j 2 पाई बाई n इंटू के एन, ठीक है। चलो अब इसमें 0 पुट करो तो a नॉट होगा, 1 पुट करो a1 इंटू e की पावर j 2 पाई बाई n। ओके, कैपिटल N कितना है 3, ओके कैपिटल N कितना है 3, पुट कर दूं तो 2 पाई बाई 3, k को पुट करो 1 तो स्मॉल n बस केवल लिखोगे क्योंकि k कितना है अभी 1। अब k को 2 पुट करो तो आप क्या लिखते हैं, a2 इंटू e की पावर j 2 पाई बाई 3 इंटू 2n, तो क्या लिखता मैं 4 पाई बाई 3 इंटू n। ओके, a नॉट a1 a2 इनके वैल्यूज कितने हैं, a नॉट a1 a2 इन सब के वैल्यूज कितने हैं 1, ठीक है। तो सबको 1 पुट करो तो आप क्या लिखते हैं 1 प्लस e की पावर j 2 पाई बाई 3 इंटू n प्लस e की पावर j 4 पाई बाई 3 इंटू n। ओके मेरे दोस्तों, अब क्या करना चाहिए, थोड़ा ध्यान से देखो, इन दोनों में आप e की पावर j पाई n कॉमन ले लो। क्यों, क्योंकि कॉमन लोगे तो यहाँ पर 2 एक्सपोनेंशियल्स आएंगे, उन दोनों के कॉम्बिनेशन से क्या फॉर्म होगा कॉस। ओके, तो e की पावर माइनस j पाई बाई 3n प्लस e की पावर j पाई बाई 3n, ऐसे हम लोग कन्वर्ट कर सकते हैं। तो फाइनली क्या लिखूंगा 1 प्लस e की पावर j पाई n इंटू 2 कॉस पाई बाई 3n। तो ये आंसर होना चाहिए 1 प्लस e की पावर j पाई n इंटू 2 कॉस पाई बाई 3n। फटाफट चेक करें, चलो 1 प्लस 2 कॉस पाई बाई 3n इंटू e की पावर j पाई n। तो ये कौन सा ऑप्शन मैच हो रहा है, ऑप्शन डी। तो इस क्वेश्चन का आंसर कौन सा ऑप्शन है, ऑप्शन डी। एक बार फिर से क्रॉस चेक कर लूं क्या, फटाफट क्रॉस चेक कर लेता हूं, 1 प्लस e की पावर j पाई n इंटू 2 कॉस पाई बाई 3n। ओके, 2 कॉस पाई बाई 3n है, ठीक है ठीक है। नेक्स्ट क्वेश्चन देखते हैं, नेक्स्ट क्वेश्चन क्या है। चलो तो नेक्स्ट क्वेश्चन इस फॉर्म में है, अपने सामने एक सिस्टम का ट्रांसफर फंक्शन गिवन है वेयर ए बी सी एंड डी आर पॉजिटिव कांस्टेंट्स। अब बताना है इनमें से ये जो सिस्टम है किस फिल्टर की तरह ट्रीट नहीं हो सकता है। ओके, आप लोग रिप्लाई कर रहे हैं क्या, मैं कोई रिप्लाई नहीं देख रहा हूं आप लोगों का। ओके ठीक है, चलो फटाफट हम लोग देख लेते हैं क्या है। देखो, अगर इसको सॉल्व करना है तो बहुत आसान तरीका, लो फ्रीक्वेंसी के लिए चेक करो, हाई फ्रीक्वेंसी के लिए चेक करो। ओके, सो एच ऑफ एस एट लो फ्रीक्वेंसी, एच ऑफ एस एट लो फ्रीक्वेंसी। तो लो फ्रीक्वेंसी के लिए एस को क्या पुट करो 0। तो जब आप एस को 0 पुट करोगे तो ये 3 टर्म 0 हो गए, कितना आया b बाई डी। तो एच ऑफ 0 इज हाउ मच b बाई डी। ओके ठीक है, नाउ ट्रांसफर फंक्शन इट मीन्स एच ऑफ एस एट हाई फ्रीक्वेंसी, ठीक है। तो हाई फ्रीक्वेंसी के लिए एस को मैं क्या पुट करूंगा इनफानाइट, एस को क्या पुट करूं इनफानाइट। तो एच ऑफ इनफानाइट, अब हम लोग चेक करें डिनोमिनेटर का ऑर्डर हायर है, इसका मतलब एच ऑफ इनफानाइट कितना 0। अब आप देखो तो एच ऑफ इनफानाइट कितना हो गया 0, इसका मतलब हाई फ्रीक्वेंसी कंपोनेंट पास नहीं होगा, और हाई फ्रीक्वेंसी कंपोनेंट पास नहीं होगा तो फिल्टर हाई पास फिल्टर की तरह ट्रीट नहीं हो सकता है. सो दिस सिस्टम कैन नॉट बी ट्रीटेड एज हाई पास फिल्टर. इसमें यही पूछा जा रहा है कि ये जो सिस्टम है किसकी तरह ऑपरेट नहीं हो सकता है. तो ये किसकी तरह ऑपरेट नहीं हो सकता है? हाई पास फिल्टर की तरह ऑपरेट नहीं हो सकता है. क्यों? क्योंकि यहाँ हाई फ्रीक्वेंसी कंपोनेंट ही पास नहीं हो रहा है और हाई पास फिल्टर होने के लिए हाई फ्रीक्वेंसी कंपोनेंट पास होना चाहिए. तो किसकी तरह ये ट्रीट नहीं हो सकता है? हाई पास फिल्टर की तरह ट्रीट नहीं हो सकता है. इसका मतलब कौन सा आंसर होगा? ऑप्शन बी. फटाफट मैं एक चीज बस क्यों लिख देता हूं, दी above system cannot be operated as, क्या लिखूं मैं, हाई पास फिल्टर. ओके, फटाफट देखूं किसी ने रिप्लाई किया है क्या? ओके, ठीक है, सुमित उपाध्याय आपका आंसर करेक्ट है. ओके, ठीक है. अब इसके बाद नेक्स्ट सब्जेक्ट है पावर सिस्टम. तो आप लोग बने रहिएगा, पावर सिस्टम के कुछ क्वेश्चन भी डिस्कस किए जाएंगे. एंड थैंक यू फॉर ज्वाइनिंग मी.
ठीक है. गुड इवनिंग बच्चों. पावर सिस्टम का हम लोग देखते हैं. मेमोरी बेस्ड क्वेश्चंस जो है उनके हम लोग सॉल्यूशन देखते हैं. सबसे पहले ये क्वेश्चन आया था हमारा
जब हम लोग GTQ डिस्कस कर रहे थे 2-3 दिन पहले ही डिस्कस किया था मैंने, मेरे ख्याल से 3-4 दिन पहले, तो मैंने आपसे कहा था कि इकोनॉमिक डिस्पैच का क्वेश्चन आएगा। आप देख सकते हैं वहाँ पे GTQ वाले सेक्शन में यूट्यूब पे जाके इकोनॉमिक डिस्पैच का क्वेश्चन आएगा, और अगर आएगा तो प्लांट इंक्रीमेंटल कॉस्ट के बारे में आपको पूछेगा। तो वहाँ पे मैंने डिटेल में 2 घंटे की टॉपिक लिया था, डिस्कस किया था GTQ, और उसमें मैंने 2 घंटे में आपको वो बेसिकली प्लांट इंक्रीमेंटल कॉस्ट ही पढ़ाया था, और वो क्वेश्चन आया है। अभी कितने मार्क्स का है मुझे एग्जैक्टली नहीं पता, हो सकता है 2 मार्क्स का हो। इसमें उन्होंने कहा है ये क्वेश्चन का स्टेटमेंट जो आपके पेपर में आया था उससे थोड़ा सा डिफरेंट हो सकता है, बट बेसिकली क्वेश्चन यही है, ठीक है। तो क्योंकि मेमोरी बेस्ड है तो एग्जैक्टली क्वेश्चन हम लोग नहीं बता सकते, बट डेटा मतलब लैंग्वेज आपके पेपर में कुछ और हो सकता है, बट क्वेश्चन वही है। उन्होंने कहा कि एक जनरेटिंग प्लांट, सॉरी यहाँ पे प्लांट होना चाहिए, एक जनरेटिंग प्लांट में जनरेटिंग यूनिट्स जो हैं वो 2 हैं, इन दोनों के लिए कॉस्ट कर्व दिया हुआ है, रुपीस पर आवर में कॉस्ट कर्व दिया हुआ है, और बेसिकली P1 प्लस P2 550 मेगावाट दिया है। मतलब डिमांड की वैल्यू कितनी दी है, डिमांड जो है P1 प्लस P2 इज इक्वल टू 550, मतलब जो दोनों यूनिट मिल के आउटपुट दे रहे हैं वो डिमांड के बराबर होगा, वो डिमांड है 550, और आपको P1 P2 की वैल्यू बतानी है, किसके लिए, प्लांट इंक्रीमेंटल कॉस्ट लैम्डा की वैल्यू 8 रुपीस पर मेगावाट आवर के लिए। तो आप समझ सकते हो कि इसमें कोई लॉस नहीं गिवन है, कोई लॉस के बारे में इंफॉर्मेशन गिवन नहीं है। तो बिकॉज लॉस नहीं गिवन है तो हम क्या समझेंगे, लॉस गिवन नहीं है और ना ही कोई लिमिट गिवन है, तो ये हमारे लिए केस 1 है। अब देख सकते हो GTQ वाले में हमने डिस्कस किया था, ये केस 1 है, क्योंकि ना लॉस दिया है, लॉस का कोई इन्फॉर्मेशन नहीं दिया और लिमिट भी नहीं कुछ दिया है, तो ये केस 1 का प्रॉब्लम है। और केस 1 में जो प्लांट इंक्रीमेंटल कॉस्ट होता है, प्लांट इंक्रीमेंटल कॉस्ट जो होता है दैट इज वेरी सिंपल, लैम्डा, इसको हम डिनोट करते हैं, दिस लैम्डा इज इक्वल टू IC1 इक्वल टू IC2 इक्वल टू लैम्डा है, और ये वैल्यू आपको दे रखा है कितना, 8। पहले तो हमको IC1 और IC2 देखना होगा कि IC1 IC2 क्या है। तो IC1 IC2 के लिए आई थिंक येलो कलर विजिबल होगा आपके लिए। तो अगर मैं देखूं तो ये कॉस्ट फंक्शन आपको दिया हुआ है, रुपीस पर आवर में कॉस्ट फंक्शन दिया हुआ है दोनों यूनिट के लिए। तो अगर मैं इंक्रीमेंटल कॉस्ट की बात करूं, IC1 की बात करूं, जो कि फंक्शन होगा P1 का, वो होगा कितना, दैट विल बी P1 जो होगा वो इसका डिफरेंशियल होगा, जो कि 0.008 P1 प्लस 6 होगा, दिस इज IC1। और सिमिलरली अगर हम इसको डिफरेंशिएट करें तो आपको IC2 आज मिल जाएगा। अगर आप बेसिकली इन्होंने F2 लिखा है, जो ज़्यादा यूज़ होता है वो C2 है, कॉस्ट के लिए हम C यूज़ करते हैं, बट इन्होंने F लिख दिया, इससे कोई फ़र्क नहीं पड़ता। यूनिट से आपको समझना है कि ये कॉस्ट के लिए आपको डेटा दिया हुआ है। तो जब हम इसको डिफ्रेंशिएट करेंगे तो हमको यूनिट 2 का इंक्रीमेंटल कॉस्ट मिलेगा, और वो हो जाएगा 0.006 P2 प्लस A होगा, ठीक है। यूनिट क्या होंगे इंक्रीमेंटल कॉस्ट के लिए, इट इज़ नथिंग बट रुपीज़ पर मेगावाट आवर। अब हमको क्या करना है, हमको IC1 इज इक्वल टू IC2 इज इक्वल टू लैम्डा इज इक्वल टू 8 रख के सॉल्व करना है, ठीक है। तो यहाँ से हम 2 इक्वेशन समझ सकते हैं, बेसिकली IC1 इज इक्वल टू 8 समझ सकते हैं, और यहीं से हमको ये भी मिलेगा IC2 इज इक्वल टू, सिमिलरली IC1 इज 8, IC2 इज 8, तो IC2 इज इक्वल टू 8। IC1 और IC2 8 रख के हम सॉल्व कर सकते हैं। अब IC1 को अगर हम 8 रखेंगे तो क्या डेटा आएगा, IC1 को अगर हम 8 रखते हैं तो 0.008 P1 प्लस 6 इज इक्वल टू 8 रखेंगे, IC1 इज इक्वल टू 8 रखेंगे, यहाँ से हमको P1 मिलेगा, और इस P1 की वैल्यू को यूज करके हम बड़े आराम से P2 की वैल्यू बता सकते हैं। तो जो P1 का डेटा है, P1 की जो वैल्यू है दैट इज नथिंग बट 8 माइनस 6 इज 2 divided by 0.008, that is nothing but 250। तो P1 है 250 मेगावाट। अगर P1 250 होगा, P1 प्लस P2 है 550, तो अगर P1 हो गया 250 तो P2 हो जाएगा माइनस दिस 300, तो P2 हो जाएगा 300। सो दिस इज द आंसर, P1 is 250, P1 is 250 and P1 is 250 and P2 is 300। so this is the answer। होपफुली बहुत सारे लोगों ने कर दिया होगा, मोस्ट सभी ने आंसर दिया। मुझे ऑप्शन नहीं पता कि इसका ऑप्शन क्या होगा, मेरे ख्याल से ऑप्शन दिया भी नहीं था, बट दिस इज द आंसर, P1 इतना होगा, P2 इतना होगा। अगर हमारा प्लांट में जो दोनों यूनिट्स हैं उनके कॉस्ट कर्व इस फॉर्म में होंगे और कोई लॉस, कोई लिमिट नहीं हमने कंसीडर किया है, तो प्लांट इंक्रीमेंटल कॉस्ट की 8 वैल्यू के लिए P1 इतना और P2 इतना होगा। ये हमको बड़े आसानी से समझ में आ रहा है। उसके बाद तो ये तो हो गया फर्स्ट जो क्वेश्चन हमने देखा था। इसके बाद इन्होंने बेसिकली, अब इस क्वेश्चन को आप पावर सिस्टम में भी समझ सकते हैं, नेटवर्क वाले लोग भी कहते हैं कि ये नेटवर्क का क्वेश्चन है, पावर सिस्टम वाले लोग भी कहते हैं। बेसिकली मैं पढ़ाता हूँ 3 फेज सर्किट में डीजी में, तो 3 फेज सर्किट के हिसाब से मैं इसको सॉल्व कर रहा हूँ, ठीक है। वैसे नहीं, कुछ लोग इसको नेटवर्क का क्वेश्चन भी कह सकते हैं, तो मैं सॉल्व कर रहा हूँ क्योंकि मैं पढ़ाता हूँ मेडीजी में 3 फेज सर्किट। इन्होंने कहा कि एक 3 फेज सप्लाई है, कैसा सप्लाई है, बैलेंस सप्लाई है, जो कितनी वैल्यू का है, 100√3 वोल्ट का है। अगर 100√3 वोल्ट गिवन है तो आपको मैंने बताया है कि 3 फेज सिस्टम में कभी भी गिवन वोल्टेज जो होता है दैट इज ऑलवेज लाइन वोल्टेज। वो लिखेगा नहीं कि ये लाइन वोल्टेज है, आपको समझना है the given voltage in a 3 phase system is always line voltage. So line voltage is this much, जो सोर्स है उसके लिए लाइन वोल्टेज की वैल्यू ये, दिस इज द लाइन वोल्टेज। सीक्वेंस एबीसी है, मैं डिटेल में आपको क्लास में एबीसी सीक्वेंस मतलब सीक्वेंस के बारे में डिटेल में पढ़ाता हूँ। एबीसी सीक्वेंस का मतलब ए फेज से बी फेज लैग करेगा, ए फेज से सी फेज लीड करेगा, और कितना लैग लीड करेगा, बिकॉज इट इज बैलेंस, तो 120 लैग 120 लीड करेगा। फिर उन्होंने कहा सीक्वेंस द वैल्यू ऑफ जेड सी, ये जो इम्पीडेंस है इस सी फेज में जो इम्पीडेंस है इसकी वैल्यू इन्होंने पूछा है जेड सी, फॉर दैट नोड एन एंड एन डैश आर एट सेम पोटेंशियल। बेसिकली सवाल ये है कि एन और एन डैश ये जो दो नोड्स हैं, इन दो नोड्स को एक ही पोटेंशियल पे रखने के लिए जेड सी की क्या वैल्यू होगी, ठीक है। तो अच्छा, जिसमें Z1 की वैल्यू दे रखा है आपको, सॉरी ZA की वैल्यू दे रखा है और ZB की वैल्यू दे रखा है। ZA और ZB की वैल्यू को देख के हमको समझ में आ रहा है कि दिस इज अ अनबैलेंस लोड, सोर्स बैलेंस है बट लोड अनबैलेंस है, ठीक है। तो बेसिक हम लॉजिक लगा के सॉल्व कर सकते हैं। अगर हमसे कहा गया कि N और N डैश एक ही पोटेंशियल पे है, तो क्या दो सेम पोटेंशियल पे अगर दो पॉइंट्स हैं तो उनके बीच में करंट फ्लो होगा? नहीं होगा। इक्वी पोटेंशियल पॉइंट्स के बीच इन्होंने बोला है, इन्होंने कहा कि एन और एन डैश सेम पोटेंशियल पे हो, उनके लिए जेड सी सॉल्व करो। तो बेसिकली हमको एन और एन डैश को एक ही पोटेंशियल पे रख के जेड सी की वैल्यू सॉल्व करनी है। अगर एन और एन डैश को हम एक ही पोटेंशियल पे समझें तो जो इसमें करंट होगा, वैसे भी ये ओपन सर्किट है तो जो करंट होगा वो कितना होगा, अगर मैं इसको ऐसे समझ लूं तो आई एन की वैल्यू हम 0 ले लेंगे, ठीक है। तो आई एन की वैल्यू हमारी 0 हो गई। अगर मैं इसको कहूं, देखो ऐसे, अगर मैं इसको कहूं कि ये आई ए है, ये हो गया आई बी, बी फेज में दिस इज आई बी, सी फेज में दिस इज आई सी, तो हमको एक चीज समझ में आ रहा है, केसीएल इक्वेशन बड़े आराम से अप्लाई करेंगे। क्या आएगा, आई ए प्लस आई बी प्लस आई सी इज इक्वल टू 0। बड़े आराम से हम समझ सकते हैं। अच्छा सॉरी, यहाँ पे हम यूज करेंगे आई ए प्लस आई बी प्लस आई सी इक्वल टू 0। आप यहाँ पे केसीएल लगा के ऐसे भी समझ सकते हैं। देखो एक ही पोटेंशियल पे हो या ना हो ये इक्वेशन तो वैलिड होगा ही, बिकॉज यहाँ से कुछ आउटपुट करंट दिख नहीं रहा, तो ये इक्वेशन तो वैलिड होगा। बट ये एक ही पोटेंशियल पे होने का मतलब क्या है कि ये पूरा ये जेडे के क्रॉस अपीयर हो, समझ लो। अगर ये दोनों एक ही पोटेंशियल पे हैं तो बेसिकली समझो तो ये वर्चुअली शॉर्ट, ठीक है, ये वर्चुअली शॉर्ट। तो अगर ये दोनों सॉर्टेड हैं तो इसका मतलब पूरा ई ए जेड ए के क्रॉस अपीयर होगा, पूरा ई बी जेड बी के क्रॉस अपीयर होगा, पूरा ई सी जेड सी के क्रॉस अपीयर होगा। इस तरह का हमने डिस्कशन किया है क्लास में, ठीक है। तो आई एन तो 0 होना ही होना है, ठीक है, क्योंकि ये ओपन सर्किटेड था। वैसे भी अगर ओपन सर्किटेड नहीं भी होता तो एक ही पोटेंशियल पे होने की वजह से आई एन 0 होता है। एक ही पोटेंशियल पे अगर दो पॉइंट्स हैं तो उनके बीच में कोई करंट फ्लो नहीं करेगा। तो आई एन को 0 रख के हमको ये इक्वेशन मिलेगा, और साथ में एक ही पोटेंशियल पे होने का मतलब ई ए पूरा यहाँ पेयर होगा, ई बी पूरा यहाँ पेयर होगा, ई सी पूरा यहाँ पेयर होगा। ये बात समझ सकते हो। तो उस हिसाब से समझो। तो देखो इस सवाल को सॉल्व करने के बहुत सारे तरीके हैं, बहुत सारे लोग इक्वेशन इसमें लिख के सॉल्व कर सकते हैं, बट मैं इसमें फेजर पसंद करूंगा सॉल्व करते समय। तो अगर मैं सपोज करो ई ए की बात करूं, यहाँ देखो, अगर मैं ई ए की बात करूं, अच्छा अगर लाइन वोल्टेज 100 है तो स्टार के हिसाब से सोचो तो ये मैग्नीट्यूड वाइज कितना होगा, मैग्नीट्यूड वाइज ये हो जाएगा, लाइन वोल्टेज 100√3 है तो फेज वोल्टेज कितना होगा, 100 वोल्ट होगा। अच्छा अगर मैं इसके फेज को 0 डिग्री ले लूं तो ये इतना हो गया, इसके हिसाब से ई बी कितना होगा, बिकॉज सोर्स बैलेंस है, तो ये अगर इतना है तो ई बी ABC सीक्वेंस में B फेज लैग करेगा तो -120 पे आएगा। मैंने इसकी फेज को 0 ले लिया, EA की फेज को 0 ले लिया, तो EB का फेज -120 पे और EC का फेज जो होगा वो +120 पे होगा। ABC सीक्वेंस में B लैग करता है, C लीड करता है, ये सब आपने पढ़ रखा है। तो अगर मैं फेजर डायग्राम बनाता हूं, सपोज करो अगर मैं फेजर डायग्राम बनाता हूं, यहां देखो ये EA, दिस इज EA, B लैग करेगा। लैगिंग के लिए कैसे बनाते हैं बेटा, आप सबको पता है लैगिंग के लिए हमको क्लॉकवाइज बनाना होता है, लीडिंग के लिए एंटी क्लॉकवाइज बनाना होता है। तो EB कुछ यहां होगा और EC यहां होगा। मैं इसको देखो समझाने में मुझे इतना टाइम लगेगा, बट एग्जाम में इतना टाइम नहीं लगेगा, आप बड़े आराम से आंसर बता सकते। EC ये होगा, ठीक है। अच्छा, पूरा EA अपीयर हो रहा है ZA के अक्रॉस, और ZA कैसा है, रेजिस्टिव, कोई इंपीडेंस कोई एंगल नहीं दिया है, मतलब रियल वैल्यू दिया है ZA के लिए, तो ZA रेजिस्टिव है। अगर ZA रेजिस्टिव है तो डेफिनेटली IA जो होगा वो इसी के फेज में होगा, और उसकी वैल्यू कितनी होगी, IA की जो वैल्यू होगी, अगर यहाँ पे बोले कि ये फेज A की करंट IA है, तो इसकी जो वैल्यू होगी वो कितनी होगी, IA कितना होगा, दिस EA अपॉन ZA, EA is 100 angle 0, ZA is 10, so IA is nothing but 10 angle 0, this is IA, ठीक है। अच्छा, IB कितनी वैल्यू का होगा, देखो ऐसे EB है 100 एंगल -120, और ये अपीयर हो रहा है ZB के क्रॉस, जहां पे ZB की ये वैल्यू है, ठीक है। तो पहले तो मैग्नीट्यूड IB की समझो, IB की जो मैग्नीट्यूड है, B फेज में करंट IB का मैग्नीट्यूड कितना होगा, जो वोल्टेज है वो 100 है मैग्नीट्यूड वाइज, और इंपीडेंस 20 है, तो बेसिकली 100 अपॉन 20 IB का मैग्नीट्यूड कितना हो जाएगा, IB का जो मैग्नीट्यूड होगा दैट वुड बी 5, मैग्नीट्यूड वाइज IB होगा 5, बिकॉज दिस इज EB अपॉन ZB। EB पूरा अपीयर होगा इसके क्रॉस, क्यों अपीयर होगा, बिकॉज सवाल में इन्होंने बोला N और N डैश एक ही पोटेंशियल पे है, इसके लिए Z से सॉल्व करो, तो हम N और N डैश को एक ही पोटेंशियल पे लेके Z से सॉल्व करेंगे। जब N और N डैश एक ही पोटेंशियल पे होंगे तो EB पूरा इसके क्रॉस अपीयर होगा, उससे हमको IB का मैग्नीट्यूड कितना मिलेगा, दिस अपॉन ZB, this voltage upon the impedance, voltage is 100 magnitude wise, impedance is 20, so magnitude wise current IB is 5। बस हमको खाली ये देखना है कि फेज क्या होगा, IB का फेज क्या होगा, ठीक है। बस एक चीज समझो, ये जो ZB है ये कैसा इंपीडेंस है, दिस इज अ लैगिंग इंपीडेंस, जो इसका इंपीडेंस एंगल है ये पॉजिटिव है, इंपीडेंस एंगल पॉजिटिव है मतलब रिएक्टेंस पॉजिटिव है, और ये किसके लिए होगा, इंडक्टिव इंपीडेंस के लिए, और इंडक्टिव इंपीडेंस में करंट लैग करता है, ये बात समझ सकते हो, करंट लैग करता है। अच्छा, लैगिंग किधर बनाते हैं बेटा, लैगिंग को बनाने के लिए आपको मैंने क्लास में बताया होगा, देखो ऐसे अगर मैं बोलूं लैग, ये थोड़ा इसका ध्यान देना पड़ रहा है, लैग जब हम दिमाग में आता है तो नेगेटिव दिमाग में आता है, और नेगेटिव को हम क्लॉकवाइज बनाते हैं। इसका मतलब क्या है हमारे लिए, इसका मतलब जब भी मुझे लैगिंग फेजर्स बनाने होंगे मैं क्लॉकवाइज बनाऊंगा, तो जो IB होगा वो EB से 60 डिग्री लैग करेगा, क्योंकि इंपीडेंस एंगल 60 है। जो IB करंट है वो EB से 60 डिग्री लैग करेगा, यानी EB से 60 डिग्री क्लॉकवाइज होगा। तो अगर EB से 60 डिग्री हम क्लॉकवाइज आएंगे तो कहां आएगा, ये 120 पे है पहले ही, ये कितने एंगल पे है, -120 पे, तो 60 डिग्री क्लॉकवाइज आके ये IB हो जाएगा कुछ यहां पे, दिस इज IB। मैग्नीट्यूड वाइज कितना होगा, मैग्नीट्यूड वाइज इट इज 5, और एंगल वाइज कितना होगा 180 डिग्री, इसको लिख लो या -180 लिख लो, जो भी मन में है वो लिख सकते हो, दोनों सेम ही है। तो IA और IB हमको मिल गया, ठीक है। IA है 10 एंगल 0, IB है 5 एंगल 180, यानी IA और IB का अगर हम रिजल्टेंट देखें तो कितना है, IA प्लस IB जो है वो कितना है, दैट इज नथिंग बट 5 एंगल 0, समझ सकते हो। IA प्लस IB, आप समझो, क्योंकि ये दोनों फेजर्स जो हैं वो एक दूसरे के जस्ट अपोजिट हैं, तो बेसिकली जब इन दोनों को हम फेजर एडिशन करेंगे तो अलजेब्रिक डिफरेंस हो जाएगा, तो दिस माइनस दिस, मतलब अगर हम इन दोनों को ऐड करेंगे तो रिजल्टेंट ये होगा। अब सोचो IA प्लस IB, कुछ ज्यादा ही टाइम ले रहा है, IA प्लस IB प्लस IC इक्वल टू 0 का मतलब IC कितना होना चाहिए, IC जो होगा वो माइनस ऑफ IA प्लस IB होना चाहिए। इसका मतलब क्या होगा, IC जो होगा वो माइनस ऑफ IA प्लस IB होगा, यानी यहां से अगर हमको IC समझना है, अगर मुझे IC को समझना है यहां से, तो IC कितना होगा, मैग्नीट्यूड वाइज तो उतना ही रहेगा 5, और एंगल वाइज कितना होगा, अगर ये 0 पे है तो IC को कितना होना चाहिए 180 पे, 180 कह लो या -180 कह लो, तो IC मुझे इतना चाहिए। अब IC होता क्या है, IC इज EC अपॉन ZC, ठीक है। आईसी हमको कैसा चाहिए, हमको आईसी चाहिए कुछ ऐसा, देखो ऐसे हमको आईसी चाहिए कुछ ऐसा, सेम वैल्यू का, आप समझो कि हमको आईसी इतना चाहिए 5 एंगल 180, ठीक है। अब इस हिसाब से सोचो तो जेडसी क्या होगा। अब देखो लॉजिक ऐसे समझो, अगर करंट आईसी मुझे चाहिए, यहां देखो आईसी मुझे चाहिए 5 एंगल 180, ठीक है, और इसको हम समझे इट इज ईसी अपॉन जेडसी, तो ये लॉजिक देखो ऐसे समझो। पहली बात तो जेडसी कैपेसिटिव करंट है, कैपेसिटिव इंपीडेंस है, तो इसका मतलब करंट लीड करेगा, किससे लीड करेगा, ईसी से आईसी लीड करेगा। हमको आईसी कहां पे चाहिए, हमको आईसी की यही वैल्यू चाहिए, आईसी की वैल्यू चाहिए कितना 5 एंगल 180, 180 कह लो या -180 कह लो। तो अगर ऐसे समझा जाए कि लीड कराना है और लीड के लिए एंटी क्लॉकवाइज बनाना है, ठीक है, ईसी से आईसी को लीड कराना है, कितने डिग्री लीड कराना है, हमको आईसी को ले आना है 5 एंगल 180 पे, इसका एंगल कितना है, ये है 100 एंगल 120। अब इससे मुझे लीड करा के 180 पे लाना है, यानी मुझे आईसी को ईसी से 60 डिग्री लीड कराना है। अब अगर मैं आईसी को ईसी से 60 डिग्री लीड कराना चाहता हूं, तो लीड कराने के लिए मुझे जो इंपीडेंस एंगल है वो -60 रखना होगा। तो इस लिहाज से मैं ये आंसर बोल दूंगा। ये दोनों तो आंसर नहीं हो सकते, ये दोनों तो आंसर है ही नहीं। तो इस हिसाब से समझो मुझे क्या कराना है, ऐसे समझो मुझे आईसी को यहां पे लाना है। ऐसे देखो IA है 10 एंगल 0, IB है 5 एंगल 180 और IC भी मुझे चाहिए 5 एंगल 180। अगर IC 5 एंगल 180 होगा, IC 5 एंगल 180 होगा, तभी IA प्लस IB प्लस IC फेजर वाइज 0 होंगे। तो अगर IA 10 एंगल 0 है, IB 5 एंगल 180 है, तो IC भी 5 एंगल 180 होना चाहिए। अब IC 5 एंगल 180 होने का मतलब EC से 60 डिग्री IC को लीड करना है। तो लीडिंग करंट कब होगा, जब इंपीडेंस एंगल नेगेटिव होगा। इंपीडेंस एंगल नेगेटिव होने का मतलब ये दोनों ऑप्शन तो है ही नहीं, तो इन दोनों में से एक होगा। और कितना लीड कराना है मुझे, आईसी को ईसी से 60 डिग्री लीड कराना है। ईसी से आईसी को 60 लीड करा के 180 पे ले आना है। तो 60 लीड करा के 180 पे लाने का मतलब इंपीडेंस एंगल 60 होगा। तो 60 के साथ क्या होगा, कैपेसिटिव इंपीडेंस होगा। तो दिस विल बी द आंसर, ये हमारा आंसर होगा 20 एंगल -60। इसको समझाने में भले ही मुझे टाइम लग रहा है, बट आप बहुत आसानी से एग्जाम में कर सकते हैं। मुझे नहीं लगता कि किसी को दिक्कत आया होगा इस क्वेश्चन में। फेजर वाइज करेंगे तो ज्यादा बेहतर है। ईसी से 60 डिग्री एंटी क्लॉकवाइज है, आईसी 60 डिग्री एंटी क्लॉकवाइज है, लीडिंग है। अब लीडिंग तभी होगा जब इंपीडेंस एंगल नेगेटिव हो, और नेगेटिव ऑप्शन इन दोनों में है। कितना लीड कराना है, 60 लीड कराना है, तो -60 इंपीडेंस एंगल होगा। सो दिस इज द वैल्यू ऑफ जेडसी। और मैग्नीट्यूड वाइज 20 क्यों होगा, आप समझो। करंट का मैग्नीट्यूड मुझे 5 चाहिए, ठीक है, और वोल्टेज है 100, तो करंट 5 तभी होगा, मैग्नीट्यूड वाइज करंट 5 तभी होगा जब इंपीडेंस 20 हो, बिकॉज वोल्टेज 100 डिवाइडेड बाय इंपीडेंस 20 विल बी द करंट आईसी 5 एम्पियर। तो ये दिस इज द आंसर। ये कोई भी कर लेगा, इसमें कोई दिक्कत नहीं है। अच्छा, इसको कुछ लोग इस क्वेश्चन को कुछ लोग मेजरमेंट का कह सकते हैं, कुछ लोग इसको बेसिकली मेजरमेंट का ही क्वेश्चन है, बट चूंकि ये 3 फेज से रिलेटेड है तो मैं इसको करा दे रहा हूं। तो हमको क्या पूछा है, मीटर की रीडिंग क्या हो गया। मीटर ये करंट को, इस करंट को क्या करेगा, इस करंट को मेजर करेगा। तो मुझे इस करंट आई की वैल्यू बतानी है, ठीक है। अच्छा, अगर मैं इस सिस्टम का परफेक्ट सर्किट बनाऊं, अगर मैं इस बैलेंस 3 फेज सिस्टम का परफेक्ट सर्किट बनाऊं, तो Z2 तो यहां आएगा क्योंकि स्टार कनेक्टेड है, ठीक है। Z2 स्टार है तो यहां आएगा, और Z2 की वैल्यू गिवन है हमको कितना, 6 प्लस J8। सो दिस इज Z2। और Z1 डेल्टा कनेक्टेड है। परफेज बनाने के लिए मुझे इक्विवेलेंट स्टार इसका बनाना होगा, और फिर उससे मुझे परफेज मिलेगा। तो Z1 जो डेल्टा में है, उसका स्टार इक्विवेलेंट के लिए डेल्टा से स्टार जाने के लिए 3 से डिवाइड करेंगे। तो बेसिकली परफेज में हमको क्या मिल जाएगा, अगर मैं Z1 को 3 से डिवाइड करूं, ये Z1 को 3 से डिवाइड करूं, तो ये हो जाएगा हमारे लिए कितना, शायद डेटा में कुछ गड़बड़ है। यहाँ Z1 की वैल्यू Z1 जो था 18 था, सॉरी, ये बेसिकली J नहीं है, ये 18 है, 18 प्लस J24। तो 18 प्लस J24 Z1 था। जब हम इसको 3 से डिवाइड करेंगे तो 6 प्लस J8 ये भी आ जाएगा, ठीक है। अब यहां से मुझे ये करंट, परफेज में ये करंट आई मिलेगा जो कि मीटर की रीडिंग होगी, ठीक है। अच्छा, वोल्टेज कितना होगा, अगर लाइन वोल्टेज 100√3 है, तो परफेज में हम फेज वोल्टेज दिखाते हैं फेज वोल्टेज 100 हो गया, ठीक है। मान लो इसके एंगल को 0, यहां से मुझे I की वैल्यू चाहिए, लेट सपोज दिस इज I1, दिस इज I2, तो I1 और I2 का सम I होगा। I1 कितना होगा, I1 हो जाएगा 100 डिवाइडेड बाई 6 प्लस J8, I1 होगा 100 एंगल 0 डिवाइडेड बाई 6 प्लस J8, और I2 हो जाएगा 100 एंगल 0 डिवाइडेड बाई 6 प्लस J8। यहाँ से आपको आंसर मिल जाएगा। बेसिकली आंसर आएगा बेसिकली आंसर आ जाएगा 10 एंगल, कितना आ जाएगा, इसका आंसर हमारे पास है 10 होगा, 5 आ रहा है। डेल्टा में कन्वर्ट, सर Z2 को डेल्टा में कन्वर्ट करना है, Z2 का है, Z2 को क्यों डेल्टा में कन्वर्ट करेंगे बेटा, Z1 को कर लेते हैं ना, Z1 को डेल्टा से स्टार में बदल दो, Z2 तो पहले से स्टार में, तो Z2 को हम क्यों करेंगे, हमने Z1 को डेल्टा से स्टार में बदला, Z2 तो पहले से ही है, तो Z2 तो ये हो गया हमारा, Z2 इज दिस मच 6 प्लस Z, ये Z2 है, और Z1 जो है वो है 18 प्लस J24, यहाँ से हमको मिल जाएगा ये 6 प्लस जब हम 3 से डिवाइड करेंगे तो 6 प्लस J8, फिर इन दोनों का पैरेलल कॉम्बिनेशन चाहो तो निकाल लो, कितना हो जाएगा, ये हो जाएगा यहाँ से I डायरेक्टली लिख सकते हैं, इट इज 100 एंगल 0 डिवाइडेड बाई इन दोनों का पैरेलल कॉम्बिनेशन बराबर इंपीडेंस है, तो डिवाइड हो जाएगा 2 से डिवाइड हो जाएगा, यानी 3 प्लस J4 जो कि कितना हो जाएगा, दिस इज 5, तो 5 ये 20 आ जाएगा। एम्पियर में इतना ही आएगा, एंगल भी समथिंग आएगा, उस एंगल से मुझे मतलब नहीं, क्योंकि मेरे ख्याल से मैग्नीट्यूड पूछा है एम्पियर में, तो ये आंसर हो जाएगा 20 एम्पियर, आंसर 10 नहीं होगा, सॉरी 20 आएगा। ये जो है दिस इज नॉट द आंसर, ये नहीं होगा हमारा आंसर, ये जब कैलकुलेशन करोगे दिस इज 20 एंगल समथिंग आएगा, तो एम्पियर की जो एमीटर की रीडिंग होगी दैट वुड बी 20 एम्पियर। इसमें जो भी था, क्वेश्चन में एग्जैक्टली क्लियर नहीं है कि इन्होंने ऑप्शन दिया था नहीं दिया था, जो भी था, तो ये हो जाएगा हमारा आंसर 20 एम्पियर, एमीटर की रीडिंग इज नथिंग बट 20 एम्पियर। अच्छा, फिर उन्होंने कहा कि एक फुली ट्रांसपोज ट्रांसमिशन लाइन के लिए पॉजिटिव, नेगेटिव और जीरो में कौन सा ऑप्शन सही है, पॉजिटिव, नेगेटिव, जीरो इंपीडेंस के लिए कौन सा ऑप्शन वैलिड ऑप्शन, तो इसमें आप सबको पता है कि फॉर ट्रांसमिशन लाइन, फॉर फुली ट्रांसपोज ट्रांसमिशन लाइन, आप सबको पता है x1 x2 सेम होंगे और x0 जो है वो ज्यादा होता है, ट्रांसमिशन लाइन में x0 ज्यादा होता है, ये डेटा हमको ध्यान रखना। मशीन के लिए x0 कम होता है, ट्रांसमिशन लाइन के लिए x0 ज्यादा होता है, तो जो ऑप्शन में x1 x2 सेम दिखे और x0 ज्यादा दिखे दैट इज द आंसर, तो ये आंसर होगा, x1 x2 सेम है और x0 ज्यादा है। अब सीक्वेंस ध्यान रखो, पॉजिटिव, नेगेटिव और जीरो की बात किया है, तो दिस इज पॉजिटिव, दिस इज नेगेटिव, ये जीरो है, बाकी किसी ऑप्शन में ये सीक्वेंस फॉलो नहीं हुआ, तो दिस इज द आंसर। जो डेटा, जो सवाल मेरे पास है उसके हिसाब से मैं आपको आंसर बता रहा हूं, तो दिस इज द आंसर। उसके बाद इन्होंने एक क्वेश्चन किया कि एक 20 MVA ये रेटिंग, इस रेटिंग का एक अल्टरनेटर है जिसका इनर्शिया कांस्टेंट 15 है, H की वैल्यू दिया है 15, H इज 15 मेगा जूल पर MVA। फिर उन्होंने कहा कि द इनपुट एंड आउटपुट पावर ऑफ अल्टरनेटर इज दिस मच, ये इनपुट है यानी ये मैकेनिकल पावर PM है और ये आउटपुट है P, दिस मच। आपसे पूछा है एंगुलर एक्सेलरेशन इन डिग्री, मैकेनिकल डिग्री पर सेकंड स्क्वायर, किसमें पूछा है, मैकेनिकल डिग्री पर सेकंड स्क्वायर में। आप सबको पता है कि जो स्विंग इक्वेशन होता है, द स्विंग इक्वेशन इज 2h अपॉन ओमेगा s, इसमें व्हाइट से लिखता हूं, मेरे ख्याल से ज्यादा विजिबल होगा, this is swing equation is 2h by omega s d square delta upon dt square is equal to pm minus pe in per unit, जहां पे ये पर यूनिट किस बेस पे रखना होता है, मशीन की रेटिंग, मशीन की पावर रेटिंग। तो बेसिकली दिस इज एक्सेलरेशन, d square delta upon dt square, this is acceleration and this is the accelerating power in per unit, ठीक है। बस खाली एक चीज का ध्यान रखना है, आपको दो चीज का ध्यान रखना होता है स्विंग इक्वेशन में, एक्सेलरेटिंग पावर इन पर यूनिट, एक्सेलरेटिंग पावर को पर यूनिट में रखना होता है और किस बेस पे पर यूनिट, मशीन की रेटिंग पे, जो हमारे क्वेश्चन में कितना दिया मशीन की रेटिंग 20 MVA, 20 MVA को बेस लेके आपको पावर एक्सेलरेटिंग पावर को पर यूनिट में रखना होगा। और दूसरा एक्सेलरेशन आपको जिस भी यूनिट में चाहिए आपको सिंक्रोनस स्पीड उसी यूनिट में रखना होगा। जब आपको एक्सेलरेशन मैकेनिकल डिग्री पर सेकंड स्क्वायर में पूछा है तो सिंक्रोनस स्पीड भी मैकेनिकल डिग्री पर सेकंड स्क्वायर में ही मैकेनिकल डिग्री पर सेकंड में ही रखना होगा। तो बहुत आसान है, कोई दिक्कत नहीं है। यहाँ से हम एक्सेलरेशन डी स्क्वायर डेल्टा अपॉन डी टी स्क्वायर, ये जो एक्सेलरेशन है इसको लिख सकते हैं कैसे, पीएम माइनस पीई इन पर यूनिट। अब ये बार बार मैं नहीं लिखूंगा कि किस बेस पे पर यूनिट है, बस ऐसे दिमाग में रखना कि पीएम और मतलब एक्सेलरेटिंग पावर की पर यूनिट वैल्यू लिखनी है मशीन की रेटिंग पे, तो पीएम माइनस पी इन पर यूनिट इंटू ओमेगा एस अपॉन दिस इज 2h, तो ये फार्मूला होगा। अब इसमें वैल्यूज क्या रखनी है, देखो ऐसे, अगर मैं एक्सेलरेटिंग पावर की बात करूं, पीएम दिया है 15, पीएम दिया है 15, पी दिया है 100, सॉरी 10, तो यहां से हमको एक्सेलरेटिंग पावर की पर यूनिट वैल्यू क्या मिलेगी, पीएम माइनस पीई इन पर यूनिट अगर चाहिए तो कितना हो जाएगा, एक्चुअल वैल्यू तो 15 माइनस 10 5 मेगावाट हो गया। बेस जो होगा हम कौन सा लेंगे, मशीन की रेटिंग, तो 20 मशीन की पावर रेटिंग है, उससे हम उससे डिवाइड करके पर यूनिट वैल्यू निकालेंगे। तो ये हो गया पीएम माइनस इन पर यूनिट विच इज 5/20, सो दिस इज 5/20, पीएम माइनस पी इन पर यूनिट इज 5/20। उसके बाद ओमेगा एस कितना रखेंगे, ओमेगा एस हमको मैकेनिकल में रखना है, आप सबको पता है 2f अपॉन पी इंटू कौन सा, मैकेनिकल डिग्री या मैकेनिकल रेडियन। अब देखो मैकेनिकल डिग्री में रखना है तो मैकेनिकल डिग्री के लिए 360, 2 इंटू 50 अपॉन पी की वैल्यू 4 और यहाँ 360। सो दिस इज द सिंक्रोनस स्पीड इन, दिस इज द सिंक्रोनस स्पीड इन कितना आ रहा है 100 इंटू 360 divided by 4 is 9000. So this is the synchronous speed 9000 mechanical degree per second. मैकेनिकल डिग्री में ही क्यों लिया है, क्योंकि हमको एक्सेलरेशन बताना मैकेनिकल डिग्री पर सेकंड स्क्वायर में। तो सिंक्रोनस स्पीड हो गया 9000 डिवाइडेड बाई 2 इंटू एच की वैल्यू होगी 15। यहाँ से जब आप सॉल्व करोगे तो एक्सेलरेशन जो है वो आ जाएगा, इसको सॉल्व करो तो ये आ जाएगा हमारा 75 मैकेनिकल डिग्रीज पर सेकेंड स्क्वायर। सो दिस इज द आंसर। तो ये क्वेश्चंस थे जो मेरे से रिलेटेड थे, ये मैंने कराया। बाकी पावर सिस्टम के जो रिमेनिंग क्वेश्चंस हैं वो दूसरे फैकल्टी करा रहे। तो होपफुली आपने अच्छा किया होगा। मिलते हैं दूसरे फैकल्टी से, आपको डिस्कस करना है बाकी के क्वेश्चंस।
Okay, dear students, let's discuss few questions, the rest questions from power system. Here the GMR of conductor, each of radius r, means self GMD we have to find out, self GMD, okay, self GMD we have to find out. So here what can I say, I can give the name to the strands A, B, C, D. So our GMR will be equal to, in the bracket, what can I say, DAA, DAB, DAC, DAD, bracket close, into, then DBA, DBB, DBC, DBD. Okay, so like this we are going to
come to the last, that is DDA, DDB, DDC, DDD, bracket close, power. How many strands are there? 1, 2, 3, 4. So I can write here 4 multiplied by 4. Now here you all know this value will be equal to this value, will be equal to this value and this value. So rather than solving continuous one by one, what can I say? I can say GMR is equal to, inside the bracket DAA, DAA, DAB, DAC, DAD power 4, and you all know very well here the power is, 4 into 4. So what is going to happen? It will be equal to DAA, DAB, DAC, DAD, bracket close, power 1 by 4. Now the point is, what is DAA? DAA, here DAA will be equal to 0.7788 into the radius. Okay, now what is DAB? This is equal to what? 2R. DAB is equal to 2R. What is DAC? Okay, so we are going to find this. This is 2R. This is 2R. So DAC will be equal to under root 2R square plus 2R square. 2R square plus 2R square will result 2R under root 2. Okay, now what is DAD? DAD is equal to 2R. DAD is equal to 2R. We are going to put all the values here, then we will get GMR. GMR inside the bracket 0.7788 into R multiplied by 2R multiplied by 2R under root 2 multiplied by 2R bracket close, power 1 by 4. So what is the solution? GMR will be equal to, it is something 1.723. The calculated data is something 1.723 R. Please calculate once and then cross check. Calculate once and cross check the calculated value. This is 1.723 R. So this is the answer. A, B, C, D. Yes, option D is available, 1.723 R. This is a very simple question and a very practical question. We used to discuss this in our class. Let's discuss the next question from power system. Yes, the question is from protection part. Power system, switchgear and protection. Theoretical question, direct question. Let's read the question. The most commonly relay used for protection against loss of excitation is, yes, it's offset Moh relay. This is the simple question, and we all know the answer of this particular question, because this is the theoretical question we have practiced and discussed many times during the discussion about switchgear and protection part of our power system. So let's start now the discussion with respect to other subjects, and then we are going to conclude few points.
So hello dear students, welcome to the GATE solution 2022 for EMT subject. So let's start from, actually there were 3 questions जो कि पूछे गए थे एग्जाम्स के अंदर, तो इसका हम एक ब्रीफ सोल्यूशन दे देते हैं, डिटेल सोल्यूशन आपको मिल जाएगा बाद में, राइट। तो पहला क्वेश्चन जो था, इट वाज एच वेक्टर दैट इज अ मैग्नेटिक फील्ड वेक्टर है एक्स स्क्वायर आई कैप, दैट इज आई कैप इज नथिंग बट योर, यू कैन से दैट इट इज नथिंग बट योर ए एक्स, है ना, इसको ए वाई के टर्म्स में भी लिख सकते हैं, दिस जे कैप इज नथिंग बट योर ए वाई, आई कैप इज नथिंग बट योर ए एक्स, और ये ए जेड होता है ना, के कैप। आपसे पूछा जा रहा है जे वेक्टर का मैग्नीट्यूड एट 1 to 1, सो इट इज वेरी सिंपल क्वेश्चन, वी नो दैट डेल क्रॉस एच इट इज इक्वल टू जे, इजंट इट, यही था। अब इसी का आपको मॉड निकालना है ना, यही निकालना था, करेक्ट। तो आप ये देखो कि जब आप इसको, मैं ब्रीफली बता देता हूं कि जे वेक्टर इट विल बी इक्वल टू, अब ये कौन सा कोऑर्डिनेट सिस्टम है, सो इट इज इन द कार्टेशियन कोऑर्डिनेट सिस्टम। कार्टेशियन कोऑर्डिनेट सिस्टम आप कैसे लिखोगे, ए एक्स ए वाई ए जेड, आप इसको आई जे कैप में भी लिख सकते हो, कोई इशू नहीं है, डेल अपॉन डेल एक्स, डेल अपॉन डेल वाई एंड डेल अपॉन डेल जेड, isn't it? अब ये हो गया आपका एक्स स्क्वायर, दिस इज योर एक्स स्क्वायर वाई स्क्वायर एंड दिस इज योर एक्स स्क्वायर वाई स्क्वायर एंड जेड स्क्वायर, है ना, ये चीज आ गया। तो जब आप इसको सॉल्व करोगे तो फाइनली यू आर गोइंग टू गेट, आई विल राइट दैट आंसर, 2x स्क्वायर वाई जेड स्क्वायर ए एक्स माइनस ऑफ 2x वाई स्क्वायर जेड स्क्वायर ए वाई प्लस 2x वाई स्क्वायर ए जेड, ये चीज आ जाएगा, है ना, जे वेक्टर आपका ये आ जाएगा। सो देयरफॉर हम क्या करेंगे, जे वेक्टर एट 1, 2, 1 अकॉर्डिंग टू द क्वेश्चन। तो जब आप 1, 2, 1 सब्स्टिट्यूट करोगे, यू विल गेट 4ax माइनस ऑफ 8ay प्लस ऑफ 8 ऑफ az। आपसे पूछा जा रहा है इसका मॉड, सो जब आप इसका मॉड लोगे तो ये आ जा रहा है 12, सो दैट मीन्स इट इज योर NAT, जो भी है मेमोरी बेस्ड क्वेश्चन है, सो आंसर इज 12, सो दिस इज द आंसर, ओके। सो दिस वाज द वन क्वेश्चन, राइट। नेक्स्ट क्वेश्चन जो है, a long conducting cylindrical body having radius b is placed on z axis and j vector is given as j naught r cube z cap, that is it is in the direction of az unit vector for r less than b, r is the radial distance, the value of h for r less than b is what, right। तो इसको कैसे सॉल्व करोगे, सो ये ऐसे क्वेश्चन ऑलरेडी हमने क्लासरूम में भी सॉल्व कर रखे हैं, ठीक है, अगर आपने देखा होगा तो उसमें आपको ऐसे क्वेश्चंस ऑलरेडी हमने कर रखे हैं। तो इसमें हम क्या लगाएंगे, एम्पेयर्स लॉ, h डॉट dl इट इज इक्वल टू करंट इनक्लोज्ड विच इज इक्वल टू सरफेस इंटीग्रल j डॉट ds, है ना। अब यहां पे j की वैल्यू कितनी दे रखी है, j इज गिवन एज j नॉट r क्यूब इन द डायरेक्शन ऑफ az, है ना, j नॉट एक कांस्टेंट है। अब मेन मुद्दा किस पे आ रहा है, ds पे। सो लेट अस सी अंडरस्टैंड हाउ टू फाइंड दिस ds, दैट इज द मोस्ट इंपॉर्टेंट थिंग। तो कौन सा कोऑर्डिनेट सिस्टम यूज किया गया, ऑब्वियसली इट इज सिलिंड्रिकल कोऑर्डिनेट सिस्टम, ये तो क्वेश्चन को देख करके आप समझ सकते हो कि इट इज सिलिंड्रिकल। तो हमें पता है कि सिलिंड्रिकल कोऑर्डिनेट सिस्टम के अंदर आप कैसे लिखते हो, लिखोगे ए आर ए थीटा ए फाई। अब आप कुछ लोग क्या होते हैं, ए रो ए फाई ए सॉरी दिस इज ए जेड, है ना, कुछ लोग रो फाई जेड। अब चूंकि क्वेश्चन में इसने आर के टर्म्स में लिखा है और चूंकि सिलिंड्रिकल के बारे में बात करा, तो इट इज बट ऑब्वियस समटाइम्स यू कैन इंटरचेंज आर विथ रो, दैट देयर इज नो प्रॉब्लम इन दैट, है ना। अब ये कितना हो जाएगा, दिस इज योर डी आर डी थीटा डी फाई 1 r एंड 1, ये होता है बेसिकली, है ना, ये चीज हमने क्लासरूम में देखा था। अब आप ये देखो इस पर्टिकुलर केस में हमें एरिया वेक्टर का डायरेक्शन क्या है, az डायरेक्शन में, तो क्या करोगे, इसको फिक्स कर दो, बचा क्या आपके पास, तो यानी कि ds वेक्टर जो हो जाएगा इट इज योर r dr d थीटा इन द डायरेक्शन ऑफ az, है ना, ये आ गया। सो दिस इज योर r d, तो यानी कि ds वेक्टर कितना आ गया, इट इज योर r dr d थीटा इन द डायरेक्शन ऑफ az, करेक्ट। अब इसमें क्या है कि सिलेंडर है, एक पार्ट है सिलेंडर का जिसका रेडियस कितना दे रखा है, इट इज b है ना, यस b है। आपसे पूछा जा रहा है जब रेडियस आपका स्मॉल r हो, है ना, वेयर r इज लेस देन b, तो इस यहां पे आपसे मैग्नेटिक फील्ड पूछा जा रहा है। तो इसका मतलब ये हो गया कि h डॉट dl मतलब क्या हो जाएगा, h इंटू 2 पाई r, है ना। तो क्लोज इंटीग्रल dl कितना हो जाएगा, 2 पाई r, इट इज इक्वल टू इंटीग्रेशन ऑफ j नॉट r क्यूब, है ना। अब चूंकि az ये डॉट प्रोडक्ट है तो az डॉट az कितना हो जाएगा, 1 हो जाएगा, ये हो जाएगा r टाइम्स dr d थीटा, है ना, ये चीज हो जाएगा। अच्छा, ये तो आपका इंटीग्रेशन हो जाएगा, तो जहां पे r की वैल्यू कहां से कहां, अच्छा डबल इंटीग्रेशन कर लो कि बिकॉज इट इज द सरफेस इंटीग्रल, तो यहां पे dr और थीटा, r की वैल्यू कहां से कहां तक लोगे, 0 से r, क्यों, क्योंकि आपसे पूछा गया है कि r लेस देन b, b से कम होना चाहिए r की वैल्यू, यानी कि 0 से लेकर के r तक। अच्छा, थीटा की वैल्यू कहां से कहां तक लोगे? सो बेसिकली इट्स बेसिकली दिस वी शुड चेंज इट विथ फाई, है ना, इसको फाई कर लेते हैं, a फाई, क्योंकि सिलिंड्रिकल कोऑर्डिनेट सिस्टम है तो इसको फाई कर लेते हैं, सो दैट ये हो जाएगा r, ये हो जाएगा d फाई, है ना। तो इसको हम चेंज करके, क्योंकि सिलिंड्रिकल कोऑर्डिनेट सिस्टम है ना, तो सिलिंड्रिकल कोऑर्डिनेट सिस्टम में जनरली क्या यूज करते हैं, रो फाई जेड होता है ना। अब यहाँ पे रो को इसने r से रिप्रेजेंट किया है, फाई को एज इट इज रहने देते, क्योंकि अगर थीटा लेंगे ना तो कुछ स्टूडेंट कंफ्यूज हो जाएंगे और थीटा की लिमिट 0 से पाई कर देंगे जो स्फेरिकल में होता है, तो इसलिए हमने इसको थोड़ा सा क्लैरिटी के लिए इसको चेंज कर दिया, है ना। तो यहाँ से फाई की वैल्यू कितनी हो जाएगी, इट विल बी 0 to 2 पाई। अब यहाँ से आपको h की वैल्यू निकालना है, तो जब आप इसको सॉल्व करोगे, तो इसको जब हमने सॉल्व किया है तो इसका वैल्यू जो निकल के आता है h की वैल्यू, इट इज कमिंग टू बी j नॉट r टू द पावर 4 अपॉन 5, ये हो गया इसकी वैल्यू, राइट। तो यानी कि j इज इक्वल h इज इक्वल टू j नॉट r टू द पावर 4 अपॉन 5, तो यानी कि इसमें ऑप्शन जो दिख रहा है दैट इज योर d, है ना, इसमें जो ऑप्शन है दैट इज योर d इज द करेक्ट आंसर। सो दीज आर ऑल मेमोरी बेस्ड क्वेश्चंस, इजंट इट? ओके, नाउ और जो लास्ट क्वेश्चन आया है, ठीक है, टोटल 3 क्वेश्चन आए थे, जो लास्ट क्वेश्चन है वो ये है कि द कंडक्टिंग स्फीयर हैज पोटेंशियल v1 at radius c and potential v2 at radius d, the correct expression for potential between c and d, है ना। तो बट ऑब्वियस है, ऐसे क्वेश्चन भी हमने किया था, ये इसमें हम क्या लगाओगे, ऑब्वियसली दिस इज क्वेश्चन इज फ्रॉम द लाप्लास इक्वेशन, है ना। लाप्लास इक्वेशन क्या है, लाप्लास इक्वेशन इज डेल स्क्वायर v इज इक्वल टू 0, है ना। कौन सा कोऑर्डिनेट सिस्टम यूज किया जा रहा है, सो दिस इज द स्फेरिकल कोऑर्डिनेट सिस्टम। तो स्फेरिकल कोऑर्डिनेट सिस्टम में h1 h2 h3 की वैल्यू कितनी होती है, 1 r एंड r ऑफ साइन थीटा, है ना, ये चीज हो गया। तो बेसिकली सो देयरफॉर डेल स्क्वायर v की वैल्यू इन स्फेरिकल कोऑर्डिनेट सिस्टम कितना हो जाएगा, ये हो जाएगा 1 अपॉन r स्क्वायर साइन थीटा डेल अपॉन डेल r, सो दिस इज योर r ऑफ साइन थीटा, है ना, ये तो दिस इज r स्क्वायर साइन थीटा डिवाइडेड बाय 1 इंटू डेल v अपॉन डेल r, है ना। चूंकि 1 डायमेंशन में है तो डेल को हम d से रिप्लेस कर सकते हैं। तो इस डिफरेंशियल इक्वेशन को आपको सॉल्व करना है, तो सॉल्व करने के बाद यू विल गेट v इज इक्वल टू माइनस ऑफ a अपॉन r प्लस b फॉर्मेट में आ जाएगा, वेयर a एंड b आर कॉन्स्टेंट्स, है ना, a और b क्या है आपका, कॉन्स्टेंट्स है, राइट। अब इसमें क्या है, ये तो इक्वेशन आ गया, यही आपसे पूछा जा रहा। अब इसके अंदर यू हैव टू पुट द वैल्यू ऑफ a एंड b, तो a और b की वैल्यू कैसे निकालोगे, तो बाउंड्री कंडीशन क्या दे रखा है कि जब r की वैल्यू आपका कितना है, r की वैल्यू जब c है तो वोल्टेज कितना है, v1 है, तो जब r की वैल्यू c है तो v की वैल्यू कितना हो गया, v1, तो हम इसको ऐसे लिख सकते हैं v1 इज इक्वल टू माइनस a अपॉन c प्लस ऑफ b, लेट अस से दिस इज इक्वेशन नंबर 1, है ना। और दूसरा जब r की वैल्यू d है तो वोल्टेज की वैल्यू कितना है, चेक कीजिए जरा, तो जब r की वैल्यू d है तो वोल्टेज की वैल्यू v2 है, तो हम क्या करेंगे, v की वैल्यू v2 यहां सब्स्टिट्यूट कर देंगे, सो दैट v2 इज इक्वल टू माइनस a अपॉन d प्लस ऑफ b। तो ये दो सॉल्व कीजिए, है ना। अब सॉल्व करने के बाद यू विल गेट द वैल्यू ऑफ a एंड b, है ना, a की वैल्यू आ जाएगी यार, यू आर गोइंग टू गेट द वैल्यू ऑफ b, सो यू हैव टू बैक सब्स्टिट्यूट a एंड b, है ना। सो सब्स्टिट्यूट a एंड b वैल्यू जो भी आएगा, substitute a and b to, let us say this is equation number a, to equation a, है ना, तो जो भी आ जाएगा that will become the answer. So you have to, that means whatever be the value of a, you have to substitute this upon r plus b, isn't it? अब fine, ये हो गया इसका फाइनल आंसर। नाउ देयर आर नो ऑप्शन, सो दिस इज आवर बेसिकली मेमोरी बेस्ड, तो इतना कैलकुलेशन, ये सारी डिटेल सोल्यूशन आपको वेबसाइट पे और इसमें मिल जाएगी, ठीक है। सो ये 3 क्वेश्चन आपके ईएमटी से आए थे, फाइन। सो आई होप वी हैव डन इट, सो थैंक यू वेरी मच।
क्या हो गया? हाँ
Hello dear students, let's start the discussion with the beautiful subject power electronics. A question from single phase full bridge rectifier. It's actually as per the data we have, it's a diode rectifier. It's a diode rectifier. So let's solve the question. Single phase full bridge rectifier. Okay, it's a single phase full bridge diode rectifier. As per the data we have, it's a diode rectifier feeding a resistive load. Feeding a resistive load. What is R? R is 50 ohm from single phase AC supply. Single phase AC supply. Single phase AC supply. So what can be the VM from the given data? That is nothing but 200 root 2 volts. 200 root 2 volts. Active power drawn by the load is. We must notice the unit, that is what. Okay, so whatever is happening, let's observe from the waveform. I am going to introduce the supply voltage waveform, and then here I am going to introduce the voltage across the load, that is output voltage waveform. Okay, the instants are very important, like this is omega t equal to 0, this is pi, now this is 2 pi. Okay, so as Vs single phase AC, Vm sin omega t, so there will be a positive half of Vs, there will be a negative half of Vs, and we all know very well, under positive half of Vs in this diode bridge rectifier, D1 D2 will turn on. During positive half of Vs, D3 D4 remain off. So what will be the V0, the voltage across the load? As it is plus Vs, as it is plus Vs, we can represent like this, as it is plus Vs, we can represent like this. But during negative half of Vs, from omega t equal to pi to 2 pi, our D1 D2 remain off, D3 D4 remain on in single phase full bridge diode rectifier. So during that period, what will be the V0? That is nothing but minus of Vs. So we will get another positive half of Vs, means positive cycle, like this, it's minus Vs. This is nothing but Vm. This peak is also Vm, and we want to calculate power. So what do we mean by power? The average output power will be equal to, for the resistive load, V0 RMS square, V0 RMS square divided by R. Obviously, you all know very well, the RMS of this waveform as well as the RMS of this waveform is going to be the same. RMS of Vs and RMS of V0 magnitude wise same. If we are going to calculate V0 RMS, we will get V0 RMS, we will get equal to Vs RMS magnitude, that is nothing but 200. That is nothing but 200 volts. So what do you mean by P0 average? P0 average will be equal to 200 square divided by the load, resistive load is now 50. So we will get after the calculation the value 800 watts. Means the answer of this question, a numerical answer type question. So we have to feed the numerical value 800 as the answer of this particular question, a simple question. Let's discuss now the next question. The next question from our chapter number 1, we can say a charger supplies 100 watt at, this is very important, 20 volts for charging the battery of the laptop. The power devices used in the converter inside the charger operates at the switching frequency of 200 kilohertz. Which power device is best suitable for this purpose?
Why we consider this particular question as of the chapter number 1 power semiconductor device? Because for a particular given application we have to select a best possible option out of the given one. So out of the given, the one of the best option for this particular low voltage and for this particular frequency range, as per the suggestion, MOSFET. MOSFET is going to be the one of the best, means the answer of this particular question is B, that is MOSFET. We all know this very well, that for high switching frequency application, for low voltage circuits, we must prefer MOSFET. So the answer is MOSFET. Okay, so guys, for the other questions, I welcome Jagdish sir. He is going to discuss the other power electronics related question. Sir, thank you दोस्त.
Hello my dear students. So this year I am very happy to say that the weightage of power electronics is increased. About 7 questions they have asked in power electronics, and first 2 questions our Sajal sir has discussed, easy questions, and let me discuss the remaining questions. So let us go through this question. Okay, just go through this question. An ideal AC to DC rectifier circuit, the load consists of DC current 15 amperes. So DC side load current is 15 amperes, constant current. Okay, and we have to find out the fundamental amplitude here. Okay, so this is a fully controlled bridge rectifier feeding high inductive load. So constant current 15 amperes. So supply current on AC side is a square wave. We have to find out the fundamental amplitude of supply current, right? So let us do this one, fundamental amplitude. So here on AC side the supply current is square wave. I hope you are all familiar with this. So this is the shape of supply current. So because the load current is constant, supply current is square wave. Positive current is I naught, negative current is minus I naught. Okay. So as the firing angle, this is alpha here. As firing angle increases, the displacement angle increases. But shape of the supply current is always same because the load current is constant. So here for square wave, how to find nth harmonic amplitude? Nth harmonic amplitude is 4 into I naught divided by n pi. So this is the amplitude of nth harmonic supply current. So what is the fundamental amplitude here? Fundamental amplitude is equal to 4 into I naught by pi. Okay. So given what is the value of I naught here? I naught value is 15 amperes. So I naught is 15 amperes. So 4 by pi into 15 amperes. So after calculating you will get about 19 amperes. So answer for this question is about 19 amperes. So on AC side of the converter the supply current is square wave. Okay. So for square wave fundamental RMS current 4 I naught by pi. So answer is 19 amperes. Okay students. So let us go to the next question. Just a minute. Okay, see the next question. So this is in a steady state current flowing through a inductor of a DC to DC buck boost converter is shown in the figure. So this is the current waveform of inductor in DC to DC buck boost converter. The peak to peak ripple in the output voltage is 1 volt. So we have to find out the output capacitance. Okay. So if you observe here, so here we have to find out the ripple in the capacitance. What is the formula for ripple in the output voltage of a capacitance? Delta V naught is equal to delta Vc. The ripple in the output voltage is same as ripple in the output filter capacitance. So that is equal to alpha into I naught by Fc. Okay. So this is the expression. Alpha is the duty ratio of the switch, I naught is the load current, frequency and capacitance. So given ripple voltage is 1 volt, alpha we can find by using this graph, I naught we have to find. So how to find I naught using this one? So here how to find IL average using this graph? So here IL is linearly rising up to 16 amperes and linearly decreasing. Okay. So whenever it is linearly increasing and linearly decreasing, how to find average value for this waveform? So average value means I maxima plus I minima. This is I maxima, this is I maximum and this is I minimum. Remember that whenever it is linearly rising and linearly decreasing, how to find average value? Average value is equal to I maximum plus I minimum divided by 2. So that is equal to 16 plus 12 divided by 2. So IL average is equal to 14 amperes, IL average. Then how to find I naught value here? So we know very well I naught is equal to I naught IL average, I naught is equal to IL average into 1 minus alpha. Okay. See, in the case of buck boost converter, the load current when the switch is off, the diode is on. See here, the switch is in the on state from here to here. When the switch is in the on state, inductor is storing energy and the current is rising linearly. So when the switch is on, this inductor current is actually the supply current. This is the supply current when the switch is on. In the second mode, when you disconnect the switch, inductor is releasing energy through the diode. Okay. So this is actually the diode current. This is actually the diode current. Here, average diode current is equal to average output current. Okay. So average diode current is equal to average output current, that is equal to average IL for 1 minus alpha or T of seconds out of T. So that is why we got this formula. So from this you can find I naught is equal to IL average is 14 amperes multiplied by 1 minus alpha means T off by time period. T off is 30 microseconds by time period is 30 plus 20, 50 microseconds. Okay. So just after calculating this, we get I naught is equal to 8.4 amperes. 8.4 amperes. Right. Now substituting here, ripple voltage is 1 volt and then duty ratio is 2 by 5. Duty ratio is 2 by 5. See, 20 divided by 20 plus 30, that is 2 by 5 into I naught is 8.4 amperes whole divided by frequency means 1 by time period. What is 1 by time period? 1 by 20 plus 30. See, 20 plus 30 microseconds. So 1 by 50 microseconds. 1 by 50 microseconds. This is, so 1 by time period is frequency into capacitance. So capacitance is unknown value here. So just calculate the value of capacitance. So if you calculate the value of capacitance, you will be getting 168 microfarads. Okay. So 168 microfarads. So 168 microfarads. I hope the concept is clear to you. So here this is the formula for rippling the output voltage. So you have to remember this formula. So first we have to find out IL average, I maxima plus I minima by 2, you will get 14 amperes. Then next I naught is equal to IL average into 1 minus alpha, find I naught, substitute here, you will get the value of filter capacitance. Okay. So now let us go through the next question. Yes. Now see here, this is the supply voltage on AC side of the rectifier, 230 into root 2 into sin omega t, and frequency is 50 hertz. The input current is 10 sin omega t minus pi by 3 plus 4 sin 3 omega t. So here this is the fundamental current, this is the fundamental current, and 3 omega. So this is the third harmonic current, this is the third harmonic current, and this is 5 omega. This is the fifth harmonic current. Okay, this is the fifth harmonic current. So we have to find out the power factor at the input side. So let us find out the power factor at the input side. Let us find out the power factor at the input side. So here whenever you calculate the power factor is equal to G into fundamental displacement factor. Here this formula is applicable only when the supply voltage is pure sinusoidal. So in our case supply voltage is pure sinusoidal. Only when the supply voltage is pure sinusoidal at fundamental frequency, then only this formula is applicable. G is the distortion factor. It is the ratio of fundamental source current and source current RMS. So let us find out the distortion factor. Fundamental source current, fundamental amplitude is 10 amperes. So fundamental RMS is 10 by square root of 2, fundamental RMS divided by, how to find RMS value of all the components? I want to find RMS value of all the components. So first RMS value of fundamental 10 by root 2 whole square, 10 by root 2 whole square plus third harmonic RMS, third harmonic amplitude 4 amperes. So third harmonic RMS is 4 by square root of 2 whole square plus fifth harmonic RMS 3 by square root of 2 whole square. So just calculate this and then substitute in this formula. So power factor is equal to G value into FDF. After calculating this, G into fundamental displacement factor is cos of pi by 3. So calculate G value and substitute here. Finally after calculating, I will tell you the answer. You will get 0.447. Power factor is 0.447. Dear students, actually this question was exactly same in our workbook, second chapter workbook, only numericals change. Okay, so this question is exactly same as our workbook in GATE ESE, right? So many questions if you see, some questions have repeated from workbook, some questions from test series, and one of the question was directly collected from GTQ. Recently we have given GTQ course, just I hope 10 days back. I will show that question also, right? Now let us go through the next question. I hope the concept is clear. So single phase inverter voltage output waveform is 50% duty cycle. 50% duty cycle means you will get square wave here. Okay, DC voltage is 1000 volts, output current is 10 sin omega t minus 60. We have to find out the active power. Dear student, just refer 10 days back. I have given GTQ course in GATE ESE YouTube channel. The same question has repeated. Just verify that one. Only numericals numbers have been changed. Otherwise the question is same. Just verify YouTube channel for GTQ course. This question is already given 10 days back. I hope you might have already gone through that. So direct question. So let me solve this question. So here this is inverter DC to AC. This is our inverter.
supply is 1000 volts. So supply voltage, this is 1000 volts DC side, okay, and AC side we have load, this is the load. They have given the equation for load current, right? Equation for load current is 10 into sine of omega t minus 60 degrees. So here the duty cycle is 50% here. So duty cycle is 50% means in this inverter these two diagonal switches given duty cycle 50% and these two diagonal switches 50%. That means we are getting square wave. So at the output side we are getting square wave, okay. So at the output side this output voltage is square wave, okay. So that is the meaning of 50% duty ratio. 50% duty ratio means these diagonal switches will conduct for half cycle and the remaining diagonal switches will conduct for half cycle. So this is Vs and this is minus Vs, okay. So when we give 50% duty ratio we get square wave at the output of inverter. That is the basic concept. Basically it is a square wave inverter. And the current waveform is pure sinusoidal here, lagging by 60 degrees. It is already given in the question. See the output current waveform. It is actually a square wave, a sinusoidal waveform. See 10 into sine omega t minus 60 degrees. So it is lagging by 60 degrees. It is lagging by 60 degrees. This is 60 degrees and its amplitude is 10 amperes. So now how to calculate the power in this case? How do you calculate the power? So just see here. So power is equal to power at the output side. Power at the output side is equal to fundamental RMS voltage into, okay. So output power is equal to, output power is same as fundamental power here. Why? Here supply current, output current is pure sinusoidal at fundamental frequency. So output power is same as fundamental power. Fundamental power is fundamental RMS voltage into RMS current into cos of, what is the phase angle difference between fundamental voltage and fundamental current? 60 degrees. Okay. Now fundamental voltage for square wave, fundamental RMS 2 root 2 by pi into Vs, supply voltage, DC supply voltage. This is fundamental RMS. Output RMS current 10 amperes is amplitude, it is 10 by square root of 2 into cos 60 is 0.5. So here supply voltage, this DC supply voltage, substitute here, this is 1000 volts. Okay students, so just calculate this value. I will tell you the calculated value. I have already calculated 3181. 3181.98 watts. Okay, 3181.98 watts. So the same question was already discussed in GTQ course. So just go through our Made Easy YouTube channel. So we have already done this 10 days back. So students are very lucky whoever referred GTQ course in Made Easy, right students? So only numericals, numbers changed in this, otherwise exactly same question, right students? So go through the next question. A three-phase voltage source converter is employed using sinusoidal PWM technique. The DC bus voltage is 1000 volts. The phase current on AC side of the converter is 10 amperes RMS value, and complex power at the output power is given minus 4000 minus J into 3000 volt amperes. We have to find out the modulation index, I mean amplitude modulation index. So I will just explain the question once again. Okay. So here 3-phase voltage source converter. This is 3-phase voltage source converter. So supply side, DC side, this is DC side. So supply voltage is 1000 volts. Okay. Supply voltage is 1000 volts. And this is the load. So this is AC side. So here V0 and I0. Given the complex power at the output, that is S is equal to the complex power S is equal to minus 400 minus J into 3000 volt amperes. This is the complex power. So in this complex power, this is the active power and this is the reactive power. Here output power is negative, active power is negative, means the power is flowing from AC to DC in fact. So that means it is working as a rectifier. The power flow from AC side to DC side. How much power is fed from AC side to DC side? Active power is 4000 watts and reactive power is 3000 VAR. Okay. So in this case, what is the expression to find out the output power? See, this is a 3-phase power. Actually, this is actually 3-phase. This is not single phase. This is actually 3-phase. So now for 3-phase power, what is the formula for 3-phase power? 3-phase power is equal to root 3 times fundamental RMS line voltage. This is fundamental RMS line voltage fundamental RMS line voltage multiplied by output RMS current into power factor. So this is the expression for output power. This is actually 3-phase. Okay, this is 3-phase AC, right? And this is actually connected to the grid. Actually, here load means this is actually connected to the grid. You need not say load, instead of saying load, so this is actually 3-phase is directly connected to the grid. Okay. So here in this case, this output power is root 3 times fundamental line voltage RMS into RMS current into power factor 1000 volts, right? And this current is 10 amperes RMS value. So phase current RMS is 10 amperes. So power is 4000. Don't take a negative sign, just take only magnitude of output power 4000 into root 3 times fundamental line voltage RMS into, this is 10 amperes. How to find power factor? When complex power is given, directly you can find out the power factor. Power factor is equal to P by S, you can write here. P means 4000. See, from complex power you can find out the power factor. Power factor is equal to active power by apparent power. What is apparent power? Apparent power is square root of active power whole square, 4000 whole square plus 3000 whole square. So this is actually power factor. Power factor is equal to active power 4000 watts divided by apparent power S is equal to square root of P square plus Q square. So here the unknown value is, just calculate this unknown value. So here fundamental line voltage RMS, after calculating this, I think you will be getting about 288.675, 288.675 volts. So this is the fundamental RMS line voltage. Now we have to find out the modulation index. So how to relate this fundamental RMS with modulation index? So we are having one formula here, 3-phase VSI sinusoidal PWM, 3-phase VSI sinusoidal PWM technique, if modulation index is less than or equal to 1, the fundamental amplitude of line voltage is, okay, root 3 times MA into Vs by 2, where Vs is the DC supply voltage. But I want fundamental line voltage RMS value. So fundamental line voltage RMS value is divided by root 2. If you divide by root 2, you will get MA times root 3 by 2 into root 2 into the DC supply voltage is 1000 volts. The DC supply voltage is 1000 volts. So here just calculate the unknown value here. So calculate the MA value here. So this is fundamental line voltage, this is 288.67. So this value is 288.67 volts, 675 volts. Okay. So the unknown value is modulation index. So just calculate the modulation index, you will get 0.47. Okay students, here you have to remember this is the expression for fundamental amplitude of line voltage when modulation index is less than or equal to 1. Okay, so first you have to remember this formula and then you can find out this fundamental voltage by using power relations. So I have clearly shown the power relations here. So output power is equal to root 3 times fundamental line voltage RMS into RMS value of output current into power factor. So output power, active power 4000 watts, it is already given. Then root 3 into fundamental RMS into, this is given, 10 amperes current is already given. Power factor means active power P divided by apparent power. What is the magnitude of apparent power? Square root of P square plus Q square. Okay. So from this you can calculate fundamental line voltage RMS. So substitute in this formula, you can find out modulation ratio. So I hope you understood. So answer is 0.47. Okay. So next. Okay. That's all now. I think that's all. I think about totally 7 questions were asked in power electronics, and questions are almost easy. If you see, one question from directly from workbook and 2 questions from test series, and one of the question was directly asked from GTQ course, right students? So almost all the questions are very easy and moderate. Okay, tough questions were not asked in power electronics. Thank you students.
Dear students, GATE 2022 Electrical Engineering Reasoning Aptitude Memory Based Questions. This year reasoning aptitude moderate and easy, and there are many questions what you have done in the classroom. So some questions memory based. Very first question, if the ring bell 1, bell 2, bell 3 ring after every 20 minutes, 30 minutes, 50 minutes respectively. Bell 1 20 minutes, bell 2 30 minutes, bell 3 will be 50 minutes. If they ring together at 12 p.m., at what time they will be ring again at together? The same similar question we have done number system. There you have done in terms of seconds, they given minutes. First of all, what you can say, your meaning of together you have take LCM for all the three. We are getting LCM around 300 minutes. 300 minutes will be 5 hours. So already given 12 o'clock, 12 plus 5 p.m. That's all. See, this all problems will be direct answers. So even though I am writing in detail,
Write down.
so LCM of all the three. First bell, second bell, third bell. They given 20 minutes, 30 minutes and 50 minutes. So LCM for all this. LCM of 20, 30, 50 will be 300 minutes. That LCM you have to find out using of the prime numbers. That 300 minutes will be 5 hours. So starting at 12 o'clock, 12 plus 5 hours. This becomes will be 5 p.m. According to given options, A is the answer. In workbook number system, we have done same similar problem. There you have taken seconds. Here we got as a minutes. That is only different. LCM for 20, 30, 50. If you want out, we can also find out using prime numbers. So this will be 25 into 12. That becomes will be 300. $25 into 12, 300.
Pen select, pen select, middle pen. Yes. Cool. Any color? Yes. Erase करना. Back button. Back. Eraser. Second. ये जस्ट इसके बगल वाला यही बस अब इरेज कर दीजिए.
So LCM 25 into 12. That becomes 300 minutes. That 300 minutes will be 5 hours. So already I completed, just even though I written once again separately, you have to find out LCM for the three categories. So every 20 minutes, every 30 minutes, every 50 minutes, all together 300 minutes. So already 12 o'clock they given, 12 plus next time 5 p.m. So it is the very first question. Coming to second.
This button, click this button.
It is the time and distance. This time and distance, our workbook first problem, there you have done similar problem. In 500 meter race, the ratio of the P and Q, 3:4. When 3 runs 3 meters, Q runs 4 meters. They given ratio. And when the race of the P start 140 meters, once it is after 140 meters, what is the distance between P and Q when P win the race? So first of all, you have to read the problem. Total distance will be 500 meters. P starting after 140, remaining only 360 meters are there. Q start from the beginning. Ratio of the 3:4. What is P is equal to 3x. 3x is equal to 360. X value 120. So when 4x value 4 into 120, 480. When P reaches end of the 500 meters, Q reaches only 480. Difference will be 20 meters. So P wins the race 20 meters. If you are writing directly, nothing wrong. But even though, we will write in detail. $500 meters. This will be Q, 140 meters. This will be P. Total distance will be 500 meters. Remaining 360 meters. So P is only after 140 meters, remaining only 360 meters. When P reaches at the last place, 500 meters, what is the winning by P? So they given clearly 3:4. P is equal to 3x, Q is equal to 4x. That 360 equal to 360, x value 120, Q is equal to 4x. 4 into 120, 480 meters. When P reaches 500 meters, P reaches 500 meters. That is the Q reaches only 480 meters. So what the difference is? 20 meters. P wins by 20 meters. If you are writing directly also, nothing wrong. Your most important 360 meters. X is 120. When P goes to at end of the 500 meters, Q goes to 4 into 120, 480. Difference will be, at P is the last place, Q is somewhere here. Difference will be 20 meters. What is the difference of here? P winning by B, Q is equal to 20 meters of race. According to given multiple choice, B is the answer. It is also time and distance. Very first problem. There you have taken 1000 meters, 900 meters, 836 meters. So that is small changings. There you got different answer. This will be 20 meters. I hope you all of you understood. Coming to third question. Third question. It is part of the percentage. There are two stores. The price of the item, by reading the problem only people get the idea. Simplifying never be complicated. Problem seems to be 4 to 5 lines. But those who have basics of percentage concepts, profit loss concepts, they can able to do. So, price of the item is 10% cheaper on online store S. There are two different stores. Store S as compared to the price of the another store M. Store S charges 150 rupees for delivery charge. So there is no delivery charge for the orders for the store M. A person bought the item from the store S and saving 100 rupees. What is the price of the item on the online store M? So they may ask price of store of M or S. We can do any one. So we can find out M, later we can find S. If there is no other charges, what is the described above? They want to find out what is the price of the store M. And this is a memory based questions. Some people told me store of M. And some people told me store of yes. So we can find out both. So there is answers are both available. According to store of M 2500, according to store of yes 2250. So let me write. So this is the store S, store M. Two different stores. Let us take M is equal to X rupees. It is a 10% cheaper. 10% you have to subtract. What is the remaining? 0.9x. 0.9x. X 10% less, subtracting 10% less, 90%, that is nothing but 0.9x. So, and also they are charging delivery charges 0.9x plus 150. What is the saving for the S? 100 rupees. Let us see once again, M is equal to X rupees, S is equal to 10% less. So we make directly 90% 0.9. Suppose if it is 100 rupees, 10 rupees less, 90 rupees. So difference of both, they given 100. So X minus 0.9 plus 150, 100. The given saving by 100. With this, it has been completed. See, by reading the problem, student has to know difference of both will be 100. They may ask store of the M or they may ask store of the S. By simplifying X value 2500. Suppose they are asking this value 0.9 into 2500, we are getting 2250. Anyway, X minus here 0.1 or directly 0.x. Minus 150 point x 100 plus 150 250 x value 250 by 0.1 that becomes 2500. So value of M is equal 2500. Suppose they are asking S value 0.9 into 2500, we are getting 2250. So M is equal to 2500, S is equal to 2250. According to our problem, M is 2500. So given multiple choice, B is the answer. Suppose they are asking S value 2250. This is a memory based questions. There is a logical reasoning problem are there, that also you have done in the classroom. So it is given by the memory based questions. Thank you for all.
Hello students. So you are all waiting for the engineering mathematics solutions for the GATE 2022 for electrical branch. So the questions are a very good number of questions we have got, and about 9 questions we have got in mathematics. So these questions I have taken based on the memory based questions from the students and some other source. Okay. So now the maximum questions are correct. So we can go with the solutions of this. Now you can check with the solutions and whether you have done the correct things or not. Now let us discuss about the first question, and all the questions have covered all the topics of engineering mathematics. Whatever we have told you that you know, the important topics of engineering mathematics. So all those things are covered here. So that is first thing. Yes, as usually we know that the linear algebra question comes in the examination, right? So the very first question is a very basic questions, okay, right? It is a types of matrix, based on the type of matrix, right? So let us look into the solution. Here Aij is given, Aij is given here, and Aij definition is given as, that is I minus j whole cube. So let me write here. Then what about this matrix is that? That is, it is symmetric or skew symmetric, identity null. Simple. Here you can see that see here, for I is equal to j, for I is equal to j, so simple aii, which are the principal diagonal elements. So this will be here, that is I minus I whole cube, which is equal to 0, which is equal to 0 here, right? So that is what. And next, suppose if I take AJI generally low triangular element, suppose. So then it is written as per the definition, it is written as j minus I whole cube, so which can be written as minus of I minus j whole cube, which is equal to minus Aij. So Aii is equal to 0 and Aij is minus of Aji. So it is, from this it is very clear that the matrix A is skew symmetric, right? So this is a classroom question or not? So basic from the definition, right? So the answer for this one is here, it is skew symmetric matrix here, it is skew symmetric matrix here, right? So we'll go to the next question, right? That is f of x. It is a you know, random variable question here on the probability side. So it is said that f of x is a PDF, right, for x. Then what is the value of this constant a? See, to find out the constants constants in the PDF, so the basic condition we use, that as we know that the total probability is equal to 1 here, so that is f of x is valid PDF. It is valid PDF if and only if integral minus infinite to infinite f of x dx is equal to 1 here. F of x dx is equal to 1 here. So then it is written as, yes, look at the function, it is mod x here. As we know that the mod x is you know, as we know that the mod x is what is exactly given, it is piecewise at 0. So therefore we split this integration at 0 here, right, and this becomes a into e power minus 2 of minus x dx here, because it is x less than 0. So mod x definition will be minus x, right, and this is a e to the power of minus 2 into x dx is equal to 1 here. Okay. So now you have to, after integrating this and equating to that, so you are going to get the a is equal to 1. You are going to get the a is equal to 1 here. Okay, right. Let's move on to the next question, dear. So it's a very easy question which we have got from the probability side here, right? So next question is that here calculus. From the calculus side, this question has been come. F of x is given here, and it's saying that f of x is decreases in which interval here? See, simple. What is the condition for f of x is going to be decreased? So f of x is to be decreased means it is very clear, that is f dash of x is less than 0. So that means we need to differentiate this integral.
So how to differentiate the integral with variable limits? By using lineage rule that we explained in the class, and same that type of problem we have got in this. Now to get this here f dash of z, so here f dash of x is equal to t by dx of integration of 0 to x e to the power of t into t minus 1 into. So can I say this one as t square minus 3t plus 2 into dt here, right? Minus 3t plus 2 into dt here. Now if you wanted to differentiate this, let's see this, how you differentiate it, right? So this is e to the power of x into x square minus 3x plus 2 into, what is the differentiation of this upper limit is x is 1 minus, now replace t by the lower limit here, that is 0. So e to the power of 0, so 0 square minus 0 plus 2, okay, this is plus 2 into what is the differentiation? What is the differentiation of this lower limit is 0. So it is 0 because it is a constant, right? So this is the way. So this is to be less than 0 for the decreasing function. So it is to be less than 0. So from this it is very clear. So this goes to be 0 and this is less than 0 means x square minus 3x plus 2 is less than 0, which implies that so 1 is less than x less than 2. So therefore, which is the correct answer? Option C is the right answer for this, right? Option C is the right answer for this 1 comma 2 here. Okay, it's very easy question, right? Yeah, but you should have a minimum basic concepts, right? So coming to this question, for the matrix is again a matrix question is been given. So this is 6A inverse is given as this, and C plus D is equal to what? It is very simple, my dear students. It's a very simple shortcut here. So you need not to do the entire concept. It is very clear that yes, you know, from this matrix we can say this 1 is the eigenvalue or not. This lambda is equal to 1, right? So therefore what I do is that, you know, from this I can write like this. From this I can write like this. I can replace this the matrix with the eigenvalue here. So I can write it as 6 by lambda is equal to lambda square plus C lambda plus D, right? Plus D, I can write this, right? So those who attended my class, so they can understand this technique. So as already lambda is equal to 1, so I can put for lambda is equal to 1, it is 6 is equal to 1 plus C plus D. So from this we are getting C plus D is equal to 5. So the answer for this question is 5 here. So the answer for this question is 5 here, right? So I think most of the students have given the correct answer. Yes, correct. Okay, very good. Yes, many of the students have given the correct answer. Yes, wonderful. Now the next question, you can see that this V bar, the matrix vector is given, and is asking the triple integral. So we have done so many questions in volume integrals, right? It's a very simple question out of them, right? It's very simple question out of them. So what is this? So let us find out first this one, okay? That is divergence of V bar. So del dot V bar, if you find it, I think you know directly. I used to do like this. So dou by dou x of this I component is 2x, and dou by dou y of this, see there is no this plus y. So dou by dou y of this one is plus 5, and this is plus 3 here, right? Because dou by dou z of this 3z is 3. So this is what you have to integrate. So now triple integral as x varies from 0 to 1. So let me write it more clearly. X varies from 0 to 1, y varies from 0 to 1, z varies from 0 to 1. Okay, so this will be of 2x plus 8 of dz, dy, and then dx. So this integration. So it's very simple integration, right? In multiple integrations we know that when we are integrating with respect to one variable, treat other variables are constant. So therefore integration of dz is z, where upper limit lower limit is 0 to 1 means it is just 1. So it is 2x plus 8 as it is, then dy and then dx.
Then again, so with respect to y, x is constant, so it is integration is x, so therefore I write it 2x plus 8 into y, right? So of integration from 0 to 1 here. So this is goes to be 0 to 1 dx, and this answer, if you do this integration of this, x square plus 8x, so 0 to 1. So this answer is going to be here 9. So 9 is the answer for this question. Okay. Yes, many of the students have got the answer. Asif Ali, Ankit, Sindhuja. So you have got the wrong answer. Now, let's move on to the next question, dear. So if A n by n is a square matrix such that lambda is the eigenvalue of A and V is the eigenvector corresponding to lambda A, consider the following two statements. See, there are two statements are given here. There are two statements are given, that is S1 and S2, right? So e power lambda is an eigenvalue of e power A. Yes, those who attended the class of diagonalization concept, so you know that the D is equal to P inverse AP. You know that from this I can say lambda D is equal to lambda A or not, right? Similarly, see, from the diagonalization concept you can write e power D is equal to P inverse e power A into P. So again I can say that, so e power lambda is the eigenvalue of e power A from this concept. Okay, from this concept we can say that. So therefore, so S1 is a true, right? And then V is an eigenvector of e power A. Yes, dear students, see, if one eigenvector is a eigenvector of a square matrix A, okay, is same for A inverse, A power n, Ka, any polynomial matrix in A. See, when you write e power A, how do you write this e power A as? That is 1 plus A square by 2 factorial plus and so on. So it is a polynomial matrix in A. So therefore the same eigenvalue will be there, sorry, same eigenvector will be there of A. So therefore S2 is also true. So therefore here both S1 and S2 are true. So option A is the right answer, right? Option A is the right answer. Okay, fine. So only few students have given the right answer. Only few students have given the right answer here, right? So next one here, this one, consider the scalar point function. Again a vector question here. So this function is given and is saying that at this point the direction, in which direction the directional derivative will be maximum. Yes, my dear students, the directional derivative or the projection will be maximum along the normal vector to the surface. So this is the surface is given. So therefore here you are supposed to find out here, that is A bar is equal to del F. A bar is equal to del F. So that is A bar is equal to del F means I dou F by dou X plus J dou F by dou Y plus K dou F by dou Z. Okay, dou F by dou Z you have to find out here. And after that, if you substitute the 1, 0, 2 as a point, right? So you are going to get this one, the 20I plus 7J plus 12K here. So this is how you are getting the answer here, right? So next question here, consider the two dice having the 6 phases. You can see this, there are 6 phases are there on the dice. There are 6 phases are there on the dice here, right? So totally you will have a n of s. What is the sample space here? See, it is the 2 dice are rolled together. So when 2 dice are rolled together, so when one die it is for 6 ways, 6 possibilities, and another die 6 possibilities. So totally the sample space will be 36. So in these cases, so what are the favorabilities of this event in which that getting any combinations of PQR? So combinations of PQR means I can write it here. Suppose this combination of PQR, if I am supposing that E is the event, so if I am supposing that E is the combination of PQR events, so I can write it here, that is PP, right, PQ, then PR, right, and then QP, then RP, right, yes or not, RP, then again RR,
then QQ, right, and RQ here. So how many have you got? 1, 2, 3, 4, 5, 6, 7, 8, and one more thing is there, that is QQ you got, RR you got, PR, RP, PQ, QP, and RQ, QR. Yes, QR. So these are the 9 possibilities you are getting. So N of E is equal to 9. So therefore the probability here will be, here N of E by N of S, that is 9 by 36. So that is 1 by 4 here. 1 by 4. Yes, very good. Yes, many students have got the right answer here. Then coming to the last question here, that is the region R in the first quadrant. See, it is very clear in this x greater than 0, y greater than 0, right? X greater than 0, y greater than 0 in this first quadrant here, right? And now by elimination technique we will go for this question, right? Right. So here we all know that if any a small parallelogram you take in this region, and what is the area element? The area element will be dx dy. But this is a small elemental area, but we want a total area of the region. So that is given by the Riemann sum. So therefore, so this is will give you area, and from this, so what is this, my dear students? So by Green's theorem I can say like this, by Green's we can derive that here this can be written as integral C x dy minus y dx is equal to 2 times of the area of the region R here, 2 times of the area of this region R. So therefore half of the integral of x dy minus y dx is also gives you the area here. So only this option A and D you can see this here. This option x dy, so this is what? This area is bounded by, so I can say like this, area under the curve, okay, bounded by x axis, bounded by y axis, and what about this one here? This is bounded by x axis, but not this kind of region R here. So therefore, so this is that which of the following is not the area of this region. So therefore here this is the answer. I can say that the answer is here C comma A comma D. A comma D are the answers, options for this one. So this is a multiple selective question here. It's a MSQ. It's a multiple selective question here. So with this I conclude that engineering mathematics questions. So we have got a n number of questions in mathematics. So I hope everyone have got the correct answers. Yes. Yes. Okay. So now with this I am concluding. So thank you so much for watching.